Fine. Yeah, so I was telling that this session will be on week 6. We will do week 6 contents. Then you will have two OPP revision kind of session, so which will primarily focus on OPP. So let me ask this question. Okay, so I am taking the first Java session for this term. I think Nalini ma'am or Kubra was taking the sessions. So let me tell you this, that when I am taking the session, you guys don't have to raise hand or ask a doubt, right? So because I will be on some other screen, so I would not be able to see if you have raised hand or something. So please go ahead, unmute yourself and ask directly. I mean, even if I'm teaching something, in between only go ahead and ask, right? Because otherwise I might not be able to listen to you later. So just at that point only interrupt me and ask in between. So that is one thing. Secondly, let me ask this question: how many of you have done I mean, those who are present here, how many of you have done some algorithmic related course or have some idea of data structures? Raise hand. I mean, just raise your hand. So who all have done that?
So I'm doing PDS simultaneously. So
Yeah, great. Then it is fine. Then it is fine. So either those who have done PDSA or those who have some idea of algorithms and maybe not algorithms, but at least data structures. How many? कितने जन है? 7 out of 15. 50% people have done some basic data. Okay, you can. Put your hands down. Thanks. So see, this week 6 is primarily about data structures. So how Java handles data structures and how we operate with them. And this is very, 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 very important with respect to both your OPP as well as your end-term OPP exam and also for your practical Java work. So whenever you are writing some real life code in Java, maybe in some industry or maybe due to some project. So this one of the collection, I mean, you will require there. The most probably you will not have any code where collection is not used. At least some collection would be used. So those who have not done any algorithm or data structure related courses, it will be a little difficult for you guys. I don't know how to solve your problem, anyways. So yeah, anyways, so while I'm teaching, you guys can interrupt and ask question if you have some fundamental idea, because I will primarily focus on the coding part. Theory part also I will try. So let me again ask one more question: do you guys have any session after this 6 to 8 slot today?
No, sir.
I mean, tell. Don't raise hand. Just unmute and tell.
sir, at 9 we have some session. Before that, nothing.
6 to 8, 9. Fine. Okay. Fine. So yeah. So then theoretical doubt also I will address. Just ask. Okay. If you don't ask, I will not see later. That is one thing. Yeah. Okay. Another thing, that how many of you have seen that code walkthrough session? I mean, many of you most probably not have seen that code
So for
walkthrough.
week 5 I have seen.
Week 5 you have seen. Okay. Week 6. I mean, I'm talking about week 6 code walkthrough.
No, sir.
No, sir.
Fine. So please see that. Okay. So before your OPP, at least, I mean, now it is fine. It's Tuesday, but before your OPP, just go and see that in detail, because most of the things are covered over there. Whatever I will teach today also, that is also there. So that is done for everyone, but for you guys can ask your doubts in between. So I will be doing that on the same, I mean, doing the discussions on the same code base, because it covers all the cases, all the corner cases, all the concepts needed to be discussed. So yeah, please go ahead and watch that session after this live session also, before your
Sir,
OPP
can
exam.
you send me the link or in
It's
chat?
there on the portal. I mean, just go like normal code walkthrough session every week is released, right? So this week also code walkthrough session is released. So just go there and see that session, right? On the portal it is there, week 6 code walkthrough session. Okay, having said all of that, let us start. My screen is visible.
Yes, sir.
Yes, sir.
Okay. Fine. So let me do it this way, that at least a brief introduction to what are data structures in general. For those, otherwise this coding session anyway will only be beneficial for the 50% of the crowd. And so basically I will go very briefly, not in details. So what is this collection framework and collections all about? So as I said, that this is basically about data structures in Java. Now what are data structures? Data structures are basically, if you are working in a code, you will need some data in that code, right? Because your code will work, just a second. Your code will work upon some data. Now the thing is, how will you represent that data in your computer program? So you have different orientations of representing that data. I mean, you can keep it in different manner, right? Your program might, might operate upon the data in different manner. So how you keep the data in your program, that decides a lot of things. Not lot of things, basically that data decides two things, and in turn those two things determine the whole performance of your program. So what are those two things? So the first thing is your space, and second thing is your time. Space means, so if same amount of data kept in a certain manner might take less space, and if it is kept in a different manner it might take more space. But accordingly, if the space is taken by the data, if more space is taken by the data in whatever representation you are following to represent that data, if more space is taken, then you will see that most of the time it takes less time to operate on that data. I mean, your program can run that data in a less amount of time. Again, vice versa, if a particular representation of data, if the code is taking much more time to work with that data, then most of the time we see that the space taken to represent that data is not that much. I mean, in less amount of space also we can represent. So this is kind of inverse proportionality. So sometimes if space is taken by the data, which is, if more space is taken by the data, then most of the time we require less time to operate on that. And if less time is, more time is taken by the program to work on that data, then most of the time space is less. This is generally observed. There are obviously some exceptions, but most of the time this is the case. So ultimately what is important, how you represent data in your program decides two factors. First is space, second is time. And these two factors in turn decides how your program will perform. Right? Now, how do you store, when I'm saying space and time, what are the different representations that I'm talking about, right? So some representations are contiguous memory representation and some are non-contiguous memory representation. So this is the first criteria, which is contiguous. I will kind of run very fast, not describing in detail, contiguous and non-contiguous. So you guys can also refer these things in detail in PDSA or in some other DS related courses. Yeah, non-contiguous and contiguous. So what do we mean by that? Contiguous data structures or contiguous representation. So representation of data are called data structure, right? And in Java we call different data structures as collections. So let me mention it over here. It's important. So representations of data, this is nothing but data structures. I'm writing in short, DS. Okay. Now in Java we call these data structures as collections, because basically you are representing a data set, and collection means what? It is a collection of something. So there it means collection of data. That's why we call it collections. Okay. So this is the logic. Okay. So contiguous and non-contiguous. What is contiguous? Contiguous means in the memory you are storing each element of that. So this is a collection of data, right? So if it is a collection of data or a data set, in the memory, each data element is stored contiguously in the memory. So your computer has a memory, right? Now in that memory, all the data will be stored one after the other. So let's say this is the first memory cell. This is the second memory cell. This is the third memory cell, right, guys? So every
Sequential.
sequentially, it is stored sequentially, right? So this is contiguous, or you can say sequential, no problem. Yeah, sequential organization or contiguous memory. And non-contiguous means what? This is not continuously located in the memory. So if your memory, I mean in your RAM, so basically when I'm saying memory, that means your RAM. So inside your random access memory or RAM, non-contiguous data representation, if you are using a non-contiguous data structure, then each of the data element will not be stored contiguously or continuously in the, or sequentially, whatever you want to say, or
Randomly.
so sequentially in the memory. So how will it be stored? It will be stored at different locations. So if I draw a very comic sketch of memory, so if let's say this is the memory, in contiguous memory location, each of the data element will be stored like this. So your first data, second data, third data, fourth data. But in non-contiguous memory representation, so this is the same memory. So let's say first data is over here. Now again we have some other datas, and then after that here I have the second data. So let's say this is second, and then again I have a lot of data dot 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 dot. Now here I have the third data. So likewise we are storing. For let's say you have an array, so the array will be stored in contiguous memory like this. But similar kind of array is by definition a contiguous memory data structure. So that's why it will be stored like this only. But just for the time being, assume that the elements of the array are stored in a non-contiguous manner. So that means the first ARR0 will be here, ARR1 will be here, ARR2 will be here, right? Likewise. Right? So this is non-contiguous memory location. So by the way, if I give a brief example, so arrays are basically example of contiguous memory data structures. So your arrays are continuously located in the memory, and non-contiguous memory locations are lists, or we say them linked list, more linked list. Okay. One example, there are many such examples. So by the way, if it is so, if how do we work with this non-contiguous memory location data representation? We have some logical links. So there will be a variable which will store the location of the next element in the memory. So the first, element will store a field in itself. That field will point to the, or give you the address of the next memory element. So in terms of Java, it is nothing but an object. So the first element, let's say this is itself a big object. Now this object will store another field inside it, or another data member inside it, and that data member is nothing but a variable that will point to, that will store the address of the next data element. And then again, this is again a new object, right? Now this object again will have a field, and that field will point to or store the address of the third data element. So this is how you work with this kind of data structure. Okay. Okay, so that was on the basis of memory alignment. Now again, on the basis of structure, we have structure. On the basis of structure, we classify data structure. Some are called linear data structure, some are called non-linear data structure. So linear data structures are arrays, lists, right? So why? Because the orientation of data is linear. It is kind of a single, in a one-line manner, right? But non-linear data structures representation will be something different. So it can be tree like this, right? Again, so if you don't know what trees are, what graphs are, then that's why I'm saying I will not go in details, but just a brief overview. So these are called trees. So since this is the structure, that's why we call it non-linear data structure. Now trees again have different kind of classification depending upon their property: binary tree, binary search tree, auto balancing tree like AVL tree, red black tree. Different kind of trees are there, right? And heaps are also kind of tree. So the problem is, with this week we will study all these things we are talking about: heaps, trees, maps. But that's why I am requesting you guys, for this OPP it is fine. For those who are not aware of this data structure, I hope this OPP will not be a lot of trouble for you, because whatever we discuss in this session, as well as just code walkthrough session, and in the upcoming mock sessions also, not mock session, the OPP revision session, if you attend those, I think it will be okay. But for later, I hope you guys will go through some real DS related content before Java, this course ends. Okay, Anyway, you have to do PDSA later, but before that also you should go and look through these things. So trees are there. Again, another thing is another type of data structure is there, which we call basically map. Now in Java we call it map. In Python, you guys are familiar with dictionary, so this is the same thing. Dictionary and maps are same thing. In Java we call map, in Python we call dictionary. So this is a completely different kind of data structure, and this is what we call, let me just not classify it under any one. So we will call it map, which is basically your Python's dictionary version. Okay, and this is implemented internally using a hash table or a binary search tree. Now, why I'm writing both of this? Because we will discuss that. One representation of map is done using binary search tree inside Java. Another representation is done using hash table. So binary search tree is done using tree map, and hash table is done for hash map. These are the Java names, Java collection names. Okay, both of these are Java collection names. So these are the internal data structure, actual name that we have, right? And this is the map. I mean, map is basically the type. So again, this is maybe the most important with respect to functioning of a lot of things. So how we make these data structures is, so we have, let's say, an element you want to put, right? So we will keep an element like this. So let's say, let me tell it like this, that we have, just a second. Let's say we have these many separate blocks, right? And each of these block is called bucket. So these are my buckets. I will come to this discussion again later, but just the structure of it, observe. So we have these buckets. Each of them are buckets. Now, let's say how many buckets are there? 0, 1, 2, 3, 4, 5. 5 buckets are there. So this is, by the way, hash table. Okay, so this is basically hash table representation. Binary search tree is something else, and we will not go into that. This is hash table representation. So 0, 1, 2, 3, 4, 5. I have numbered it, and these are called buckets, each of these memory location. Okay, these can be contiguously located in memory, may not be contiguously located. We are not worried about that. Let us just have a logical understanding that these are the buckets. Now, what do we mean by bucket? So bucket numbers are basically, or bucket IDs. So these are bucket IDs, 0, 1, 2, 3, 4. So bucket IDs are basically set so that a hash function can give a result. I mean, a resultant value of the hash function must correspond to each of these bucket value. Now, what do we mean by that statement? So let's say you want to store a set of values in a hash table, right? Or in terms of Java, you want to store a set of values in a hash map. Okay, so we will see all of this in code. Don't get worried if you have some partial understanding of it. So we will see them in code. So if you want to store some element in a hash map, how will it work? So you are just writing, let's say, .add, and that will add your, I mean, some add function is there, and you just write that add function, or put function is there, whatever, we will see that. So you can write that put function, and it will put the element into your hash map. Now, how internally is that working? So whatever value you are putting, that value, let's say the value is x, right? Your value. So x is your entered value or number or whatever, x. Now, what is done on x, we will apply a function h. So h of x. So this h is nothing but a hash function. We call it hash function. So this hash function will work on x, and it will generate a result. So whatever result it will generate, right? Whatever result it will generate, that result will be nothing but the ID of the bucket ID. Okay, that will be the, yeah.
Sir,
Go
in
ahead.
Java also this is called probing, linear probing, quadratic probing.
Yeah, probing is basically not generating the hash ID. Probing is basically, if there is a collision, then what you do. I mean, if it is linear probing, you just check the next value, right? So yeah, probing in Java, we will not be worried about all of that, because internally all of that probing and collision resolution will be handled by Java's internal mechanism. So we are not worried about that from the coding perspective, right? Yeah. So, but if you want to just go how it actually happens, if you want to see, then you can go to the hash map code, and then you can see that how probing is done. I mean, you will understand because the hash function will have that plus some iterator value, right? I, whatever number of collision it is, so that I will be there, and it may be quadratic, it may be quadratic probing is also used, some max, I mean, salting and hashing, double hashing is also used. So there are many ways of doing that. So I have not seen how Java internally does that, and it is not all, I mean, from coding perspective, it's not important for us. So because that is collision resolution, right?
Okay. Okay, sir.
So yeah, you can check that. If you're interested, just go into the hash map code and see how the collision is handled.
Sure.
Okay, so then we have generated this bucket ID, and now because this bucket ID is generated, now I can see that X has been put into the hash function, and after putting it into the hash function, this bucket ID is generated, and therefore I will put X in the corresponding bucket ID. Now let us, for this example, I am taking a hash function example, I mean hash function sample. So let it be modulus 6, right? X modulus 6, or whatever you give, right? Whatever you give, modulus 6 is the hash function. So let us say I enter 34, X is equal to 34. Then in which bucket should I put 34? Any?
4. 4.
4, right? Why? Because
Four,
if I correct, if I divide 34 by 6, I will get 5 6 ja 30, and 4 will be remainder. Modulus function gives the remainder value. So since this is the hash function, therefore I told you whatever be the, yeah, whatever be the result, that will be the bucket ID. So in 4 we will store the element 34. Sorry, not here. So basically how we store it. Okay, let us keep it here only. Just a second. Fine, 34 is stored. Now let's say I put X equal to 12, right? So in 0, right? Then I put X equal to 36. Now what I can do? What will I do?
In 1 we will store.
Yeah, so there is the point. Now we don't know how, I mean, generally there are two ways to handle it. Either I can store this 36, since 36 will point to this 0 bucket, right? So either I can store it in case of the next available bucket. Now since 0 is already filled up with 12, I can fill up 36 in the 1 number bucket. But there can be another way. So that other way is I can store array kind of, not array, I am not using the exact term. The exact term is we will make a linked list, but since I have not yet discussed what linked lists are, so basically we will make a linked list kind of structure over here. So assume that we will create another memory location, and we will point to that memory location using an object, and in this memory location after 12 we will store 36. So this means that 36 is also in the bucket of 0, okay, but there is something already there inside 0 bucket, which is 12. So therefore I will put 36 in the same bucket but into another memory location. So for our current situation, we will assume that this is how it works. I will not store 36 in 1. Okay, now both of these strategies have separate name, right? Open hashing, closed hashing, chaining, these things are there. So this is basically chaining. So you don't have to worry about all of that as of now. For your Java's programming point of view, just assume that this is the way it is done. So whenever I get a same bucket value or bucket ID generated, I will store it like this. Again, if I get, let's say next X value is equal to 18, then again I will get 0, right? So then again I will store 18 over here. Okay, then let's say I get X equal to 20, right? Then I will store it as 2.
So then there is no collision here.
Yeah, here. Sorry, what?
No, there is no collision. Like we are not considering collision.
So yeah, we are considering collision. When collision is happening, then I'm storing this linked list kind of structure, right? This is what called open hashing, right? So whenever you are getting into collision, you are creating a new memory location as the linked list and putting it that. I mean, this is the second policy of handling collision. First policy is closed hashing, where you basically generate a second ID to put that same number, and the second way of working with this kind of situation is called open hashing. So in open hashing or chaining, which we also call chaining, In open hashing strategy, we put it like this. Okay.
Yes.
Yeah. Okay. So we will study these things in PDS in detail. So don't get worried. So now let's say I got 20. Then let's say again X is 21. So if it is 21, where will I put it? Here, right? 21 filled up. Then let's say I get again 36, 38. X equal to 38. So again 38 will be stored here. So you observe that this is how we will do the creation of hash map. So please have this structure in your mind. Now one problem is there. Now I tell you how to search. If I want to search a particular number in this representation, how will I do the searching? So let's say I ask you that I want to search whether the number, let's say 94, whether 94 is present or not in this data representation. Now how will you do? First of all, since you already know that whatever number I am putting into the data structure hash map, I will have done some hash function work on that, right? So I will have put hash function on that number, and whatever result it had generated, I must have put that 94 number into that bucket ID. So therefore, when I am asked to search the number 94, what I will do is I will again apply the hash function and see what bucket ID it is generating. So what bucket ID it will generate? I think 30, 72, 4, right? Okay. 90, yeah, correct. So anyways, so I will go over here and I will see that 34 is there, right? So already it is there, and then should I just directly stop after seeing that 34 is there? No. Why? Because there can be some elements after 34 also. I mean, just in this case it is not there, but there might be some element. So there is another checking which I must have to do, and that is basically, is there any other element in the sequence or not? So let's say if I want to search a number which is a multiple of 6, so let's say some number 60, if the next number that I need to search is 60, so then I will get to the bucket value 0, and then I see that 12 is there. So should I stop? No. Then again I have to check that what are the other numbers in this bucket, and maybe if I don't find at the end also 18, that, and after 18 no number is there, so that means 60 is not there in the structure. So I will search through all the number. So there are 2 points of searching. Please keep this thing in mind, because this is what we will do explicitly. We will code it. 2 things are there. First is the hash function. So in hash map, and this point is very, very important with respect to your OPP is also. First point is checking on the basis of hash function. Okay, hash function. And the second point is checking among the items in the same bucket. Okay, so these are the 2 things, 2 checks will happen. Now I will mention why, because this first one, checking on the basis of hash function, how will you, if I need to customize sometimes, right? We will see such situation in this session only. If I sometimes need to customize the way hash function is getting, I mean the hash function is generating the ID value, bucket ID value. Sometimes I need to customize it. Okay, I don't want to deal with the whole inner level of complexity of the hash function, but I want some features of the hash function to be something that I want. I mean, to be something like this. Now, what is something like this and what I want, all these things will be clear once I go into the code. But let us just now, I mean, believe this thing that you want to have some features of the hash function working in a specific manner. Not the whole hash function, but some features should be according to what you want. Okay. So as I said, let me give it a little more detail. So here I am, what I'm doing, x%6, x modulus 6. Now let's say
duplicate not allowed, no? Or is
duplicate,
it duplicate elements?
yeah,
So,
duplicate. So that in hash map it is allowed. I mean, we will also see that there is another data structure called set. I will go to that. In set, duplicates are not allowed. In map, duplicate is allowed. Right? There is something called hash set. I will just discuss that after this. Hash set. In hash set, or in any set, basically, the set data structure doesn't allow duplicates. Map allows duplicates. Okay, map allows duplicates means, again there are some details, again I will go to the code and tell. Duplicate means you cannot have a key value duplicated. I mean the value field can be, so in Python you have this key and value in case of dictionary, right? In maps also you will have key and value. Now if the key value you are talking about duplicate, no, key value cannot be duplicated in map. But the whole pair, I mean, let's say you have a different key value, but the key field is different, but the value field is same, then that is allowed. But set will not allow even any duplicate. No duplicates are allowed in set. Okay, map only prohibits you from having same key values. Set prohibits you from having any kind of duplicate. Okay, fine. So coming to this map discussion, which I was telling, the checking on the basis of hash function. Here I am basically doing x%6. Now let's say x is, here it's a number, but now let's say x is, in real life I change the situation and tell you x is student roll number, a student object. X is a student object. Now what will this mean? Student %6 is meaningless, right? A student reference %6 means nothing. It's wrong, right? So what I rather want is, you have to do student roll number %6. I mean student object has, let's say student name is there, let's say student's marks is there, some marks field is there, let's say which class he is, that is there, and then let's say his roll number is there. Okay, now I want this roll number field to be associated with the x%6. So I should do roll number, student dot roll number %6. But hash function by default it will work on the whole object, right? Whatever value you put inside the memory, I mean this structure I told you, on that whole value hash function will operate. So then hash function will operate on the whole student object by default. But you don't want that. You want only roll number field to be the field which the hash function should work upon. So in such kind of requirement you might have, you don't want to see the details of how the hash function is working, but you might have some desires like this, that I want the hash function to work on any one particular field or in any one particular way. Okay, so in that kind of situation we have to override the hash code method. Now what is this hash code method? Where is it coming from? We will discuss in detail, don't worry. Just keep this thing in mind, that there is something like this, and we will visit that at the end of this session. So we will override hash code method to apply this kind of customized behavior of the hash function. And the second thing is checking among the items in the same bucket. That is done by overriding the equals method. Now equals and hash codes are the two methods that you have to learn to override on the basis of the requirement that has been asked of you. And by overriding these two things, we can have this hash map in a more customized way that we want. Okay.
So this equals will be used for traversal, is it?
This equals will be used to compare between the, just a second now. Yeah, sorry for that. Fine. So yeah, you are asking something, right?
You're telling about equals. How
equals is for this equals is for this internal comparison. I told you two comparison is there, right? So the first is bucket selection. Bucket selection will be done by the hash code method, and that's how we have to override hash code. And the second is within the bucket. Now this 12's hash code is also 0, 30's hash code is also 0, 18's hash code is also 0. So now once you are inside it, okay, you use this you have to override this equals method. Why you have to override this equals method? We will see that. But basically, briefly saying that equals method is also already, I mean, implemented method, right? And that method will have some comparison condition, right? How you will do the equal. Now that method will only check equality on the basis of object address. So even if you have 18, let's say 18 is there, and let's say another 18 is there, both of their object ID is different, but their values are same. In that case, equals will say that they are not same. The default implementation of equal will say they are not same because the objects are different. But you want the equality to be judged on the basis of value and not object. So in such a situation, you have to override equals method. We will see that. We will see such example. Don't worry.
So basically, this equals will be used to check equality while we are traversing this particular chain.
Within a bucket.
Yes. Okay.
Within a bucket. So once you getting into a bucket, customization of that, or I mean, so this is what I told, right? If you want to do the hash code to work on any one of the field, that kind of customization you can gain by overriding the hash code method.
Yes.
And that's why we will need to do the hash code. And now once bucket is selected, still your task is not yet done, because inside the bucket you can have many elements. Now inside that, the comparing between different elements within the bucket, there you need to use the override equals method, right?
So this hash code is a predefined class?
That those things we will come in the basic. Just have this basic idea, and we will come to those things in the code.
Okay.
In equals method, we are comparing value, right?
Correct. Let me give you a real example. You will understand why I am talking about this equals thing. So let's say the objects that I am talking about is students. Again, coming back to the students object, right? And let's say there is some particular field called student ID, or let's say the name field only. Name is not a good field, but let us say name is the field that is the key value. So you guys are familiar with Python dictionary. So as of now, by the way, in hash map, we will, or hash table, whatever, hash table is the structure and hash map is the Java's name of this structure. So basically in a hash map, everything will be like stored in a dictionary. So it will have a key and it will have a value. So the student object that I'm talking about, let us assume the key is name of the student, and the value is the whole object. Okay, the student object. The object itself is the value, and the name field of that object is the key. Just for now, just suppose this is the situation. Okay, now you want to do the equality check on the basis of marks. You got the point? So you have objects in the hash map, and the objects are basically student objects, and they are represented like this key value pair. And the key value pair means the key is the name, value is the object itself. Now, if this is the way we are representing the whole thing inside the hash map, okay, so then I want to check the equality on the basis of marks. So I want to also generate the hash code on the basis of marks. Getting the point? Hash code will be generated on the basis of marks, and also the equality of objects will be checked on the basis of marks. So this has nothing to do with the key name. Key is just the way, because in dictionary kind of structure, we need a key and a value. So the key is name and value is object. This is how your data structure will look like, a sequence of key value pairs. That is fine. But where I put inside implementation, right, inside the memory implementation of the data structure, where I put a particular object will be decided by the marks. Let us say, just for example, okay, will be decided by the marks field of the student. And so in such a situation, we will do marks %6. So x is nothing but marks. Like here, I mean, this value will be whatever marks of that particular student object %6. Now by that we will get a bucket ID, and we will put that key value pair corresponding to that entry or that object, whatever you want to say, in that particular bucket. Now let's say that is this bucket, right? This bucket I have put the first value. But let's say then again another value came, which is this bucket, and then again another value came, which is this bucket. Sorry, not this bucket, this same buckets, and that's why so I'm putting one after the other. But all of these are put on the basis of marks. Just for an example, take that. Just we are doing it on the basis of marks. Now, once you have put these values on the basis of marks, right? So I told you the equality of objects should also be done on the basis of marks itself. So if you are getting confused, let me remove these 12, 18 things, right? So as of now, assume this is the scenario of the data structure. Internally, you have 3 objects or 3 key value pairs. Sorry, this. You have 3 key value pairs. So the first I have let's say key 1 value 1, key 2 value 2, key 3 value 3. Okay, this is the way it is stored. But the point is, when I have put this key value pairs on the hash function %6, it gave me the bucket 0, and that hash function was working upon only the marks of the value, which is the object. So only the marks of the object, right? So that is done. So I have configured the hash code method, and it has done this x %6, where x is only the student dot marks. Now this is done.
So
Now
it is
once
x mod modulus 6 or x %6?
modulus 6. Percent sign means modulus sign, right? In computer science. I hope these things you are aware of, right?
Yes.
Yes, sir.
So okay, so now you have put these objects in this, I mean, in the same bucket. Now I ask you that equals, why do I need this equals method? So you see that bucket 0 has k1 v1, k2 v2, k3 v3. Now what is the equality condition? These are just simple 3 objects, and accordingly the key value is that object's name. How will you compare between them? I mean, since I told you that once we are doing this hash map, once we have figured out the bucket, then we have to check whether the element that I am searching is at all that particular element or not. Okay, the element I am searching has mapped to 0 bucket. That is fine. But inside 0 bucket, there are many elements. So I have to figure out whether my element is there in the 0 bucket or not. So in order to figure that out, I need to check equality of the object inside 0 bucket and the object that I am trying to find. I have to check the equality. Now, by default, the equality of object is checked by address, right? Object address. Now, object address will anyway be different, because every time you are creating an object, a new address is assigned to that object, correct? So the default equal method will always give that both the objects are different, even if the marks field is same. I told you the hash code and equality will both be done on the basis of marks. I mean, I want such a condition where the hash code generation as well as the equality of 2 objects will be done on the basis of marks. So basically, I'm trying to find a particular student who has the same marks, something like this, right? So if this is the situation, then whatever marks, even if the marks that I'm giving that is there inside the data structure, then also my equals, normal equals method will give me, it is not present, because for that normal equals method, as soon as you create a new object, it is a different value. So at that point, I want to tell equals method that you should not do the comparison on the basis of your object address or memory address. Rather, you should do it on the basis of the marks field of the student. Only the marks field, and nothing else should bother. I mean, nothing else should be taken into account while comparing 2 objects equality. Okay, so this I want to tell the equals method. How can I do that? I can override the equals method. So once I override the equals method, on the basis of that overridden version, the equality will be checked, and then I can just check the equality on the basis of marks. And then if, let's say, K2 v2 entry, which is the object for the key K2, that object's marks field has the same marks as I am searching. So then equality for equal function will work, and it will tell, okay, K2 v2 is there, which is basically the object that you are searching. So that's why we need to override the equals method. Now, if you say that where are these equals and hash code methods are coming from, that we will see very soon. But is the basic thing okay? Understood?
Sir?
Yes.
Yeah, go ahead. Go
Sir,
ahead.
the implementation wherein you are saying that the equals will compare only the marks, won't it be erroneous? Because the thing is, because for a bucket we can have multiple students having same marks. Their identities are different, sir.
I'm not going into the details of the whether I want to compare on the basis of marks. They can have multiple values. They can have multiple values. Fine, let it give me one value. I'm not worried about the. See, I'm not talking in details about the situation, case study.
Okay.
I'm
Got
talking
it.
about the concept. Okay.
Yeah. Yes.
So yeah, case study can be many things that we will discuss when we go into the code, right? We will discuss that in detail. Yeah. Go ahead. Tell. Fast.
Sir, you have taken, sir, key name and value is equal to object. So what is the object? Value is marks there, but you have taken value is equal to object.
No. Why marks will that object is basically storing the whole thing, right? Now inside that object we'll have the name, roll number, marks, class, whatever. All the fields are there. Now I want the marks field to be considered while checking equality, right? So I need that only. Okay, so how this is internally operating once we go into the code will be clear. So I will skip it for now. Just please have a let's say a boundary, a basic outline of what hash maps looks like and how hash maps work, because these two things will be very important with respect to your coding perspective. But I will not go into the exact details of how this works. That you have to do it on your own. I mean the data structure concept part. Okay, so the next thing that I will talk about is set. Okay, now set is again another data structure, and again because internal implementation is not important with respect to Java course, we will not go into the details of how set implementation is done internally. But let us assume set is such a data structure which can do very fast searching, and it does not allow duplicates. Okay, does not allow duplicates. That is, I think, the main property of set. Does not allow duplicates. So even if you put a duplicate inside a set, right, it will automatically remove it. So let's say you put 107821227, right? Something like this you put inside a set. How you put, we will see all of that. But once you put, it will allow you to put all of this number. But then after you have put all the numbers, you simply print the set. So the print contents will be 10782. Okay, so this will be printed. So that is set, and again we will have two kinds of set. First is hash set, and second is tree set. Now there are a lot of things to discuss between both of these, but again they are internal implementation and algorithmic discussion. I will not do that here. But basically in terms of programming, if you want to differentiate between these two, hash set will not give you does not give sorted data. Implicitly sorts data. So basically, if this is the string, this is the input string that you are putting inside both hash set and tree set, right? Your hash set's result will be this. I mean, after that, if you are printing, right, printing the hash set, println, right? After you do println, if you print the hash set, so this will be the result. Now, if you print the tree set on the same data input, the result will be something like this: 0, 1, 2, 7, 8. Okay, so tree set also will remove the duplicates automatically, but it will also print the data in this sorted manner. Fine. So yeah, that is one thing. Another important point before going into the coding discussion is that how the structure of your collection framework is coded or it is set in Java. But I will not discuss that because it is already kind of 7. So I will go into the coding part now. So, but I will request all of you to check that code walkthrough session. In that we have discussed in detail why the different interfaces, the classes. I have also shown the code bases where that classes are coming from, the internally written code of Java libraries of each of these classes. All those things we have discussed. So please go through that. I will not discuss that as a part of this live session because that will take some time. I will directly go into the coding part. So what I mean is so let's say we have this list, right? List, integer, array list. So what is this list? Is this list a class? Is this obviously you can understand from here that not obviously, basically, yeah. So basically you can't understand. So list might be a class, list might be a abstract class, list might be a interface. It can be a lot of things. So you don't know what list is. So you need to have a basic idea of all those things. What is this list so I said it is an interface. So what is this list interface? What are collections interface? What is collection class? There are a lot of things. So those basic structure, but that is not very important with respect to your coding part, but it is very important with respect to your understanding of how the collection framework is made, so that if you run into trouble in some situation, you can, kind of bypass that trouble. If you understand the whole structure, it will be easy for you to figure out what's happening. So please go through that structure of the collection framework and how it is made. And that's why Professor Madhavan has taught the first lecture of this week as indirection. So why indirection and why interfaces is important. So that structure of collection framework is very important. I am saying again and again, go through that part. I will not do that in this session. Okay. So let us go to the coding then. Till now, any doubt, anyone, or anything you want to ask? Go ahead and ask.
No, sir. Sir, could you please zoom in the screen?
Zoom in the screen. Okay. Is it not visible properly? I am kind of.
Now fine, sir.
Okay.
Sir, like in the first lecture, Madhavan sir told that list is the interface, and array list is that concrete implementation.
Correct.
So by this indirection, the thing which is helpful is when we declare a list, we can declare it as list. So only when we need it, we can at the time when we need it, we can create new array list.
Correct.
So we are like postponing that.
Correct.
So the advantage is only that in the initialization we don't have to write array list, right? But still, wherever if you want to change the code, then everywhere we have to change, right? Like
No. See. So I have not discussed the whole code yet, but let us give a brief summary of what you are telling. So this is the list, a list, array list. Fine, something is there. I will discuss all of this in detail, but as of now, just think list, a list, array list. Okay. So I have worked everywhere in the code normally, and let us say here again, after some time, I want to do some changes in the array list part, and I want to change this array list to something else. Some let's say linked list. Okay, linked list is also a list, and linked list is a concrete class implementation of list. Now, at later point, I want that without you. Sorry, I was using array list. That is fine, but now my data is so big that array list is kind of. I don't want to use array list. I want to use a linked list. Okay, so if you would have written here array list, let's say if this was the code that you have written, right, then also there is no error. As you see, there are no errors in this code. Everything is working.
Yes.
If you have written this, then later at some point, so I'm just keeping this code, I'm not deleting because you have some things in mind. So yeah, so after doing a lot of stuff over here, let's say I'm commenting, and let us assume that here I've done a lot of some code using this a list, let's say we have to use a list.add, right, some value 67 colon. So just assume that there are a lot of tasks I have done using this a list method. Okay, so let us uncomment. If you are not sure about it, let us uncomment and let us show you. Right, so we have this a list.add is also there. Now just assume that this add, there is only one statement used, but assume that there are lots of adds and lots of things you have done using this a list method, a list reference. Okay, assume there are lots of lines of code.
Yes.
Okay, sir. That is fine. Now you have done this. Now after doing a lot of tasks, so yeah, so here you have done till here you have done a lot of tasks done. So at this point you want to see that, you are seeing that you have a lot of data, and now you want to change the internal implementation to some other kind of data structure. Maybe you don't like this array list anymore. You want some, because of the newly generated data on which you are working or the complexity of the code, you want to change the data structure, right? So what you do, if you just directly go over here and try to change the data structure, then it is showing, you see that this is showing error. Why? Because we are putting a linked list into an array list kind of reference variable. That is not allowed. Because linked list and array list are two siblings. They are two sibling classes. Fine. So sibling classes of the same interface. But if I would have done here, instead of array list, simple list, and initially it was, let's say, array list, so everything was fine, right? This A list is working. If you see, this A list is still fine even when I am deleted. Observe, this is the thing that you have to observe. Earlier it was array list. I have done the array list add method. So a list.add, it was fine. Now I have changed this to list. Still a list.add is fine. It is working. It is not showing any trouble. Okay. Now if I at later point I decide that okay, I don't want this. I just want to have a linked list. See, till now we have used a lot of a list here also, a list.size, a list.get, a list.add. So many a lists we have used. What I will do is I will just go over here. I don't want an array list anymore. That's it. Finish. Is there any error?
No, sir.
This is the power. So if you would have done this using array list, then it would not have worked, as I showed you earlier. So if you would have done it directly using an array list, then you see that then it is showing error. You cannot do it. So this is the indirection that professor has talked about.
So then if we change that array list to linked list in the left side, like instead of list,
correct.
if you write array list and there will be error, then if you write linked list in the left side also, then that whole A list data will be lost. Okay, if we change.
Yeah, the thing is that if you do that, if you change the reference only, then again later point, at some point you again have to change the whole thing. Getting it? So list can store any kind of data structure. It can store linked list, array list, whatever you want. But if you store a more concrete type reference, if you use a more concrete type reference, then that flexibility is lost, right? So you can also have this list, a list. So it might so happen in your code that let's take such an example that you have done a part of code and you have created a package. Oh wait, package, I think you guys have still not completed, right? Okay, fine. So let me just tell it like this. So let's say that you have written a part of code and your friend will also work on that. So your work is a specific module. You are creating a module of code and your friend will operate on that module. Now that means what? Your friend will not write code on the same program that you have written. He will use the features written by you to write a code. So this is like Python's import. So you guys import a lot of libraries and do work on the functions, right? Do you write the functions on your own? No, you are importing the library and using it. So let us say you have written a library in Java. Now how to write a library, we will see that later. But let us say you have done that. Now while you are writing that library, you don't know what concrete implementation your friend might need. He might need an array list, he might need a linked list, he might need some other kind of linked hash list. There are many things. So maybe he might need different kind of stuff. But you don't know what kind of concrete class he might need while he is coding by using your library or your functions. So it is safe side for you to use a list reference variable, right? So when your friend uses a concrete class, so whatever concrete class he chooses to use your written method, right? So whatever concrete class he chooses, the object of that concrete class can be passed to the reference variable that you have chosen. If you have chosen a linked list type reference variable, and if he chooses an array list class, then while writing his code by using your package, I mean your library functions or your written code, he cannot do anything. He will see error because you inside the code you have written, you have used an array list interface and array list reference variable, and he is using a linked list linked list object. So therefore it is not allowed. So if you used using list reference variable, then he will not have to change anything of your code because anyway he does not have access to your code, right? In Python, when you are importing something and working on the functions, by using importing. You are not going into the library and changing those library functions, right? You are simply importing it and using the functions. So something like that, right? So this is one practical example why this is important. Indirection is useful. Got the point?
Yes, sir. So if you implement array list, a list, then if another person imports a list, then he cannot assign linked list.
Correct.
Otherwise, okay. Since we are using list, he can use anything.
Correct.
And also one more doubt, sir. Instead of list, you had previously written array list on left side, like reference area. And then if you wanted to change it to linked list, then also like in two places you have to change, in both the right side and reference area.
Yeah, that is so there. That is obviously will be there. But still again, you can argue that, okay, I will change in just two places. That is also not that much difficult, right? Changing in one place, and here I am changing in two places. Yeah, you can argue that here also it is not a lot of job, just two places you are changing. Obviously, if you use list, only one place you have to change, only right side. But even if you just change the array list to linked list on left hand side, that also works. So why I am going into this list thing? So in such an argument, I will give you this example where you have to write a package or you have to write a code, and at that point you don't know what concrete class your friend or other person who is using that library function will use. So in such a situation, it is absolutely compulsory to use a reference of list type, because if you use other type of reference, forget about changing code at one place, changing code at two place. You don't have to deal with any of that because your code will not work. Because the guy who is writing code by importing your library, it will not work at all if he chooses some other type, right? So then even by changing it will not work because your library is fixed. You are no longer in the story. You have gone out. You are now working from some other company. Now the new developer who has come into your company, now he is using a pre-written code base which is done by you when 2 years ago you were employee of that company, and now you have gone out and you have used a linked list type of reference variable. The new employee will be worried that why this pre-written code is not working. And then he will see that you have written the package using a list type of reference variable, and that is not a good, an array list kind of reference variable, and that is not a good practice to do because you have done a concrete implementation. So concrete implementation while making library code should never be done. You should have that flexibility, right? So this is not only about changing one place to place. This is about, it will work or it will not work. That kind of situation. It's much more important.
Yes, so you're saying like importing a list, so that will throw error if you don't write list.
Correct.
Okay.
Sir, I have a basic question.
Go ahead,
in Java, this list and this array list, linked list, these are predefined classes, is it?
All of these are predefined. Yeah, that's why I'm saying, since I'm kind of short on time, I cannot discuss the structure. This is why I told you that you guys have to go through the structure, go through that code walkthrough session. So list is a interface. Okay. Now list interface. So if I go over here, anyway, I have to, you see, public interface, list, extend, sequenced collection. So what are all these things? Don't have to worry about all of that. But as of now, just understand that list is what? An interface. Okay. So list is an interface. Now linked list is a class.
Which is extending list.
Yeah, which is implementing list. There are a lot of other things which it is doing. It is extending abstract sequential list. It is implementing list. Lot of things. So that's why I told code walkthrough session I have discussed each of these.
Sure.
Okay. So yeah, linked list is a concrete class. Array list is a concrete class. List is an interface. And I hope you guys are familiar with generics type now. So yeah, we are basically creating a list of integer in this line. Okay, a list of integer, and we are, as I told you, that there are two kind of data structure: contiguous, non-contiguous. Linked list is a non-contiguous data structure. Array list is a contiguous data structure. I think that this was array list earlier. Right, array list. So at first I am creating an array list. So it is basically an array only, but internally it is represented in some manner. I am not worried about that. You can assume that this is an array. The only benefit is if you want to write a normal array, then you have to write the size of the array, right? So let's say integer array you want to create. So integer ARR equal to new int. Can I leave it like this? You cannot, right? You have to, so if you have to provide some size, right? But what if I don't know what is the size at current time? I want to just, whatever my program will take in, it should take in as much data as it wants. So let's say I want to take user input. So user will enter values and that I will be storing inside my program. So at the, while I'm writing the code, I don't know how many values the user will put, right? So what will I put in the size of the array? Then I have to tell the user that, okay, you can put maximum 10 value because my array size is 10. That is not something practical, right? So I want a feature that will allow me to dynamically take input and store it, but it will be kind of an array only. So if I want such a feature, then I want this a list, right? Otherwise, another thing you can do, you can tell the user, okay, at first you tell me how many input you want to give, then you can take that in a variable, and then you can create a new array using that variable. That is okay, but then again you are putting a restriction on the user. User might say, okay, I also don't know how many values I want to give. I just want to I mean go with it and see how many values at the end it generates, something like that. So then if I want such a feature, then you have to go with this kind of implementation. We define this list, array list, and now a list is basically a kind of an array, and we will use different function to work upon it. Idea in your mind, it should be like an array, but in order to work with it, we will see some basic function. So if you want to add values in this a list, then we will use the add function. You see this add function is there. I am running a loop from 1 to 10 and I am using a list.add. So add is used for putting value into this array. Okay, now inside add, whatever value I give, it will be taken in, and this is a generic type. You see all the collections are generic type, but here since I've used this integer as the type, therefore I will only put integer value. Now what is this fib function doing? Fib function is a Fibonacci number generator. You guys know Fibonacci numbers, right?
Yes, sir.
Yes.
Okay, so
Yes.
So the fib function is basically a Fibonacci number generator. If I go down somewhere, yeah. So here I have defined the Fibonacci function, public static integer fib, right?
So this add method also you defined somewhere, or it's
Already there. I don't have to do anything because now you have imported this linked list object, right? Not imported, basically you are using this linked list object, define this linked list object. Array list, sorry, not array list, sorry, not linked list, array list. You have defined this new array list, right? So now this new array list class has all these methods implemented. All you have to do is just define this array list, import the library. Okay, I forgot to tell that. This you have to write this statement. Since you are using these things, I mean, therefore you have to import whatever you are trying to use, right? Like Python. So that's why you have to write this Java import java.util.star. Okay. Now what is this thing? What does this mean? Import java.util. What is it? Java dot. What is util dot? All these doubts will be cleared when you learn packages. Packages is there, and I think week 7. Yeah, I think in week 7 it is there. So yeah. As of now, ignore all of that. Just think that you have to write this line. Like Python you import, here also you will import. Once you do the importing, you can use the array list object to use this method add and all of these things. Okay. I have not written anything what is there, I mean, other than what is there on the screen, right? Everything is already pre-implemented. So you are using this array list object to use this function add and all these things.
Sir, one advantage of this array list compared to the pre-existing that Java array is that size can be variable, right?
Yeah, that's what I told, no? Yeah. So yeah, so you are adding the Fibonacci numbers, Fibonacci 1, 2, 3, 4, like that I'm doing, and adding into the array list, and then I'm printing the array list. Now, how can I print the array list? So you see I equal to 0, normal array, how do you do? Whatever be the array length, right? So here also I'm doing a list dot size. So this dot size dot add, these are the things that you have to keep in mind by practice, or you have to refer to the documentary. Sorry, not documentary, documentation. In the documentation, it will, all these functions will be provided, and in your OPP also you will have the access to documentation. So if you are not that well in practice, then you have to refer to the documentation a lot of times. That will take some time, right? Okay. So So yeah, so
Then
this
both
size,
the OPPs, the documentation will be provided.
yeah. Otherwise, it is impossible to code.
Okay.
We are not expecting you guys to remember all the function of each of the object. No one can do that. No one can do that basically. Yeah. So yeah, so documentation will be provided. You guys are free to go to the documentation, and whatever you type, it will give you the list of function and all the things with definition and return type, whatever. All the things you can refer that. Yeah, but practice code, because then if you go to documentation a lot of time, it will take some time, right? You have to write the code also. 3 programs you have to write, so it is important. So this dot size method is used to check the size, and then in order to get, right, if I want to now write a value, you do dot add function. Reading a value, you use the dot get function. So whatever I write the index, right, in array, normal array, how do you do? ARR I. So this will bring you the value, right? So here we cannot do this ARR I. What we will do is we will put a colon, and we will do ARR dot get. So this will give me the resultant, I mean, read the I index value, right? So that's what we are doing, alist dot get I. Okay, fine. And this is that add that I talked about anyway. Okay, so that's it. Simple array list, 3 things. In order to iterate through it, we use size. In order to reading from it, you use get, and in order to adding into it, you use the add method over here. Okay, now we will learn linked list. Linked list also functionally we do not have anything else. Adding, going through it, reading data, something like that only. So likewise, same here also add, nothing different. Just like that, we are adding here also. Just here we are adding from 11 to 20 Fibonacci numbers. Okay, and yeah. After that, what we are going to do over here, change every even element to 0. Now see, this is very important. Please observe over here what's going to happen, because this is a common pattern in case of most of the collection that we will talk about. Okay, this is very, very important. Just see this. So first, adding the numbers into the linked list is fine. That we added. Okay. After that, what we are trying to do in line number 26, we told you that change every element to 0, even element to 0. Okay, so in order to change every even element to 0, what I need to do is I need to go through each of the element of the array, and then I have to check whether it is even or not, and then not array, linked list I mean. Yeah, I have to go through each element of the linked list, check whether it is even or not, and then I have to do the job that I have been told, which is basically convert the element to 0. Okay, so then that means I have to traverse through the linked list. Like, so how did we traverse through the array? We traverse through the array using a loop, right? Right? We have a loop, and it was going till size, and we were traversing. Here what we are using it, because linked list does not work on the basis of indices. I mean, you can traverse through the linked list on the basis of indices, but it's not a good thing to do. So there is another way to do that, and that is using these extended for loops or advanced for loops, or some people call it for each loop, whatever be the name you use. So this is kind of a different kind of for loop. I mean, in Python it might be similar. For Python coders it is quite similar, but for Java it is something new. So what we are doing over here is we are traversing through the linked list L list by writing this integer x. That means the x will go through each of the element inside this L list in each of the iteration of the for loop. Normal. I mean, so every time a iteration of the for loop proceeds, it will go through the element of the L list and store that corresponding element for that iteration in the x variable. Okay, so this is what we call a for each loop. Okay, so then I am writing I'm printing the element of the linked list. This is basically printing the element. Then we are checking if it is even or not. If the value is even, then what I need to do, I told you we need to change it, right? Now x is what? X, since I am not traversing through a index based traversal, we are basically going through each of the element, as I told. So that means x is the element, not the index. Now if x is the element, and then what I am doing over here, list.index of x. I am trying to find the index of x. So this index of function, which is internally defined, again all these functions are internally defined, right? So if you write list, which is the linked list object. Once I put the dot, you will see all these functions coming: add all, add first, add last, clear, contains. All these functions are internally defined. You can use them. Okay, now here it is coming like this suggestion. In your exam, it will not come like this. You will not need also. You will need just add, search. I mean, this add, remove, this some simple size, index of, contains, this little things, right? But anyways, if you forget about it, you can refer the documentation. Anyway, so you find the index of the value x, and that index I am storing in the temp variable, and then I am using list.set method. Again, this set is also a predefined function. Set method, right? To do what? To first argument inside the set method is the index, that which index value you want to set. So that is the index I am providing, and then in the second item I am providing the value with which I want to change the element at the given index. So the set method will change the value of the element at the given index, the index being the first argument of the set method, right? It will change it to the value that you are giving in the second argument. So it will change the index of the, so whatever value is there inside the index of x, which is basically x. Now you will say that then anyway we got x, so why we are using this index searching thing? The reason is the set method works like that. The set methods needs the index. It does not want to work with the value, right? If it would have worked with the value, then instead of writing list.set temp, I would have written list.set x, because then it would have found the value of the x element and it would have removed that to 0. But it doesn't work like that. What it does is you give an index, then and it will remove, or it will change the value of data present at that index. So that's why I need to find the index, and I'm therefore using the index of function. Okay.
So for a linked list, using this type of for each loop is efficient, right? Otherwise, if you use that for I, like that range,
correct,
I equal to 0, I plus, then
correct,
each time the linked list will go from starting, right?
Exactly.
Whereas this in a single loop, it will go.
Yeah.
It will not go again and again.
Exactly. Correct. But yeah, so that's why. So now I did not mention that point explicitly. I think sir has mentioned it, but I did not. I'm not going into that, because then we have to discuss, for those who do not understand the working of linked list, how the performance is getting better or not. So yeah. Anyways, so just assume
What is element colon 0?
Colon 0 means this is the syntax. So you put integer x colon 0, that colon list, L list you are talking about, right? Line 27.
Yeah.
That is basically
Line 31.
Line 31.
So basically the ID is helping you.
Wait. Achha, sorry. This is nothing. This is kind of
ID feature.
Yeah. So that is ID is automatically adding this element thing. I mean, don't worry. So it is basically, wait, I will show you. So if I write temp, comma, I will write only 0. That element will come as an ID feature. It tells you that this is the second. So you see the syntax, I mean this set index, the signature, right? It is showing set int index integer element. So basically the second parameter is
Our
nothing
element is x, right?
our element is x. So when I'm writing, our element is not x. Our element is the value that I want to change the value of x with. So since here I want to change the value of x with 0, that's why our element is 0 in this case, right? So the value with which you want to modify the old value, that is your element. So if I write
the replacement value we have to mention over there.
Replacement value, yeah. Replacement value, if I write 0, then see automatically it will add this element. I mean, just a kind of representation. Okay. So it's nothing, you don't have to write element colon. Yeah.
So this element is defined internally in linked list, that implementation.
Yeah. So the set method, okay, so let us go to the set method. Yeah, you see the set method, this is the definition of the set method. Not the definition, the signature of the set method. We have the int index e element, a generic type element. So that's why that element was coming in there automatically. Okay. By the way, here you see that this is a colon is given. That means it's a abstract function, right? Why? Because it is a part of the interface list. It is not an implementation function. Where is the implementation of this function?
maybe array list or linked list.
Correct, in the concrete class, which is the array list or the linked list class, right? In this case we are talking about linked list, so the implementation is in the linked list class. If you go in the linked list class, there you will find the set method. Anyways, so we have used this kind of for loop to iterate through the linked list, right? And we have learned a few methods, index of and set. Okay, fine. Now if I print it, right, if I, let's say, run this code, array list was printed here, the linked list is printed over here. Okay, and then we have this, just a second, let me just, where did that code go? Yeah, change every element, even element to 0. So if I go over here, yeah, so this was the linked list, and then every even element will be converted to 0. So 144 is an even element, see it is converted to 0. 610 is even, converted to 0. 2584 is even, converted to 0, right? Okay.
So where did we define this modified line?
Modified we have not yet come, it will come later. Okay, so I have, when I'm writing, the whole code is getting executed, right? So we have not yet reached this part, we will read that now.
Okay.
So after that, what we are doing is, let me uncomment this. Okay, so remove every alternate element with 0 as value. So now we have converted the even element to be 0, and now I am asking you to remove every alternate element with 0 as value. So whatever 0, whichever element is 0 in our list, I want to remove the alternate zeros. So I will not remove the first 0 in the linked list, but I will remove the second 0. Again, third 0 I will not remove, fourth 0 I will remove. Alternate zeros will be removed, right? So this is in essence nothing different from the first loop, right? What did we do over here? We basically iterated through the linked list using a for loop and the value. So x is basically, in each iteration, x is one value of the linked list, and in the subsequent iteration, x is the next value in the linked list. So I am just iterating through the linked list on the basis of value. Now if here I change the even numbers to 0 using the set method, but now I have been asked to remove the alternate 0 element. So again I will traverse through the linked list in the same way using a for loop, like just exactly the same line of code that I am writing over here, same line of code, right? But here the condition will change. If the value is 0, that is the first condition. Yeah, if x is equal to 0, right? Then it flag. So this is the alternate checking, right? Because I will remove alternate zeros, I told. So we have this Boolean flag over here, which is initially set to false, and therefore the first condition when I'm checking if will be false. So I don't want to remove the first 0, but then I am making the flag inverted so that in the second iteration the flag becomes 1. The flag becomes true, and that's when in the second iteration I will remove the next 0, right? So simple code, but here the idea is, again I am traversing using the same for loop. Again since I have found the correct element, if the flag works, if the flag is true, then inside this if condition at line number 41, now I am at a position to remove the value, right? Because both x is equal to 0 and also flag equal to true, which is basically I am at the alternate 0, therefore I want to remove this 0. So inside this if condition at line 41, I am at the correct index. I am at such a value of the x variable which has to be removed, right? So I am doing again list.index of x. So I get the index from here. Once I get the index of here, I write list.remove index. So whatever value is there in the index will be removed. Just like the same, just like the previous for loop, there we were updating the value, here we are deleting the value. Nothing.
Sir, like if x equal to 0 should not be there, right? Because if the current code will not do anything. Like for 0 it will enter, but
that is anyway not there. We have inputted Fibonacci numbers, right? So I think I have imported from 1 only. But yeah, as of now, assume that 0, I mean, all the things that we have converted to 0, they are only, I mean, real numbers were only there. Only, so I think linked list we have input from 11 to 20. Fibonacci numbers from index 11 to index 20 Fibonacci numbers, right? So even 11, on any, none of them will be 0 anyways. So yeah.
Then it will not enter this flag.
What? It will not?
Enter the 40th line, the flag. If flag.
Yeah. So it will enter in one iteration, in the next 0 it will not enter. Again it will enter in the third 0, not enter on the fourth 0. Or otherwise, I mean, if it enters on the first 0, in the second one it will not enter. Right.
Okay, before this we made even positions as 0.
Correct. Right. So yeah, so then I'm removing, since I'm inside it, I'm removing the index 0. Sorry, not index 0, the value where 0 is present, that is there inside this index variable. So what I'm trying to focus more is the similarity between these two lines, these two things. Right. Here also I'm traversing using this loop, here also I'm traversing using this loop. Obviously the job I am doing is a little bit different, that's why the functions I've used are different. But you see, then again, once I find the correct element, here using the if statement, and here using these two if statement, I am finding the correct element. Now once I have found the correct element, inside here I am using the index of method, here also I have finding the index of method. Once I get the index, then I am here using the remove to remove that element. Here I was basically trying to modify that element, so here we were using the set function, and here I am using the remove function. So essentially in idea they are both same. Job I am doing different, but the structure of the code is same. Right. So if I execute this code, so what happened? Okay, so let me again execute it. Yeah, so you see that we are getting an exception. So till printing the linked list, it is fine. So something happened in the code that we just wrote, right, over this code. This code, something happened. It is showing concurrent modification exception. But in the previous case, it was not showing. Here also the code was same.
So basically, we are iterating over the loop and modifying that data structure both together. That's why it's giving.
Here also we are modifying the data structure by changing the value.
We were just changing the value, so we were not removing from the array. It's
Correct.
the list.
Correct.
Linked list structure was not changed.
Correct. So have this idea in mind. Many of the students think both of the places we are changing the data structure. So why it is happening? Yeah, in the first case you are changing, but you are changing the value. The structure of the data structure is not getting changed. The physical structure remains same. Only the internal value inside one of the node is getting changed. But in the second case, you are completely removing a particular node. That's why the physical structure of the DS data structure or the linked list in this case is getting changed, right? And because of that, there is a concurrent modification exception. Now, why concurrent modification exception? So there is something called iterator. Now, what are iterators? Iterators are a kind of a variable. Again, this is discussed in detail in that walkthrough session and also in Sir's lecture. Please see Sir's lecture at first. So iterators are basically a variable, a kind of variable which can be used to iterate through any collection type. Okay. Now, if you see the structure of the collection framework, you will understand, because iterator is basically comes from a interface which is called iterable, and iterable is the topmost hierarchy interface in the collection framework. Okay, so I will go through these things not in detail, because that's why I'm saying again and again, watch that live coding, that walkthrough session and Sir's lecture, right? So this iterable is an interface, and using that interface, you can, I mean, most of the collection classes, concrete classes will implement that interface indirectly, right? Indirectly, they will implement that interface. And since that iterator interface is used in all the collection classes, that's why we can have a iterator type reference variable, and later on we can also have a concrete variable, I mean, an instance variable of iterator to travel through different data structures. right? Now what is iterator we have yet not seen. Just listen to the definition as of now. Iterators are basically variables, or let's say a class object. That class of what class we are talking about, I am not going into that, we will see that just after this. So they are basically instance variables that can be used to iterate through different data structures, or in case of Java, different collections. Okay, fine. Now why are iterators important? You see the for loop that we wrote in these two lines, both in line 38 and in line 27, both these for loops internally uses iterators. So I am writing integer x L list, and later on integer x, yeah, both the cases integer x L list. So here for your sake you are writing like this, but internally Java is using a iterator to iterate through the L list. Okay, so that complexity is modularized from you, it is not given to you. Okay, so but internally it is using that. Now when the for loop itself is using one iterator, you are iterating through the through the data structure, or the list, in this case linked list, and then you remove the element, one element from this data structure. If that iterator is not informed about this decision that an element is removed, then the iterator, since it is iterating on the data structure, it will get confused later on. Why it will get confused? Because the iterator knows that the size of the data structure is this much, right? So it knows that the size of the data structure is, let's say, 10 elements to L, size of L list is, let's say, 10 elements. Now internally this for loop is using iterator, that's what I told. So that means the iterator which is working internally knows the size of L list to be 10. So that means this for loop will run 10 times. That's what the iterator knows internally. But then again, in one of the iterations of the for loop, you are basically removing one of the value. Now this information is, if not passed to the iterator, if the iterator is not informed about this new change in the structure of the collection or the linked list, then the iterator will get confused, because it had thought that there are 10 elements, but again the number of, since it was iterating once, again and again, it was at some point it got stopped and it saw that okay, there are only 9 elements. So then it will get confused, it will say, okay, what happened to one element? There must have been some problem while the code was running. So before that happens, the Java compiler, not the Java compiler, the Java runtime system throws the concurrent modification exception. That is why concurrent, because the iterator was already working on your data structure or your collection. Modification, why? Because they have modified that data structure. So that's why it says concurrent modification exception. So then this is kind of a very common operation, right? Traveling through a data structure and removing an element from it. So how to then do that? See, the problem is not occurring because you are removing. The problem is occurring because you are removing it, not informing it to the iterator. And that iterator is working behind the scenes of the for loop, right? That is the whole story. So you need to somehow inform the iterator. How to inform the iterator? So there is no explicit way of informing the iterator. The way to do that is using the iterator methods itself. So you need to do this whole code on the basis of iterators. Now we will see how to do that with iterator, but for the time being, keep one thing in mind. Whenever you are modifying the physical structure of a collection type, it can be a linked list, it can be a map, it can be a whatever different, we will see that, right? Any collection you talk about, if you modify the structure by removing an element or adding an element, and that removal or addition of element happens inside the loop, inside the for loop, while you are traveling or traversing through that collection, then you definitely have to use the iterator. You cannot use a normal for loop like this to change the structure of the collection type. This is applicable for linked list, this is applicable for set, this is applicable for hash map, everything. Okay, normal, when you are changing the value or doing some other operation, for loop will be enough. But if you are using you doing something to change the structure, then you have to use iterator, and for loop will not work. So therefore I will comment this part. Right? And now we will see how to do it using the iterator. So now we are writing the modified linked list. Okay. So we saw the problem of concurrent modification exception. So now we will use the iterator. You see now how we do with the iterator. So this line is very important. So this list dot list iterator. So a list dot list iterator. So this list iterator method of linked list class, if I go to the definition, what happened? Okay, wait. You see, so this is the function that I'm talking about. Yeah, public list iterator. This is the function list iterator, right? And yeah, so it is basically returning your list ITR. Again, these structures I have explained in the walkthrough session. Just visit that. So we have this list iterator thing. Over here, this function I am calling. So which classes function is that? Linked list classes function. So any linked list class object can call this function. So I'm using this, where did it go? Yeah, so this list is a linked list class object dot list iterator function. So list iterator will return one iterator to me to traverse through the linked list. So what is iterator? I told you it is a reference variable or instance, whatever you want to call it. It is an instance which is used to iterate through a collection type. So since it is used to iterate through the collections, each collection will have a method to give a iterator instance to itself, right? Each collection will have a method to give or return a iterator instance to itself, so that that collection can be traversed. So therefore here I am using the linked list iterator generation instance, which is basically list iterator method. So I'm calling the list iterator method to get a iterator instance. Now where will I store this iterator instance? So this is iterator class, right? And I have to provide the generic type of value which I will work upon. So list has integer value, right? While defining list, we saw list is integer. So that's why the iterator will also go through integral values. So therefore I am writing over here iterator integer. Okay, you can spread a bit more. There are many subclasses of iterator also. So you can write list iterator also. Then also the code will work. But you don't have to worry about so many classes and all of that. Just assume that if you write iterator, then also it is fine. So iterator integer ITR equal to list dot list iterator. So this method will be associated with different, this method will be different methods for each collection type. So in this case, it is list iterator. In some other method, it will be something else. Get iterator might be there. Some other method will be there. But every collection will have some iterator providing method that will provide the iterator instance, and using that iterator instance, you can work upon that collection. Now, so we have now got a iterator instance, and I told you this iterator is basically used to traverse through the data structure internally. Now we will see how it is done. So here we will not use any for loop or anything like that. Here we have this has next method. So this has next method of the iterator object will tell you if there is something still left in the data structure to be read. Okay. So as long as there is something in the data structure which is not read, this has next will return true. So we are writing while itr dot has next. So if there are some elements, until and unless there are no element in the list, then the while method will, only when there are no elements in the list and has next returns false, then only the while loop will terminate. Okay, so itr dot has next. Then I am coming to the next method. Now what is this next method doing? Next method will read the next element in the collection. Simply that. So next element. So itr dot next. So inside the while loop, I am reading the next element in the sequence. Okay, then I am checking the val and flag and all those things. And if it is the correct element that has to be removed, then I will simply write itr dot remove. Now, one question might come to your mind that hey, in the previous case, we are providing the index that is the element that I want to remove. So like here, if I go, here the remove method has the index. So I was providing the index that this is the element I want to remove. But here in the iterator version, we are not using any index. Remove is just normally. So how does remove understand which element to remove?
Value is equal to 0. you have written if value is
That is a
equal to-
condition. If value is 0, if flag 2 is holding true, then I'm writing itr.remove. But inside the itr.remove line, have I anywhere provided the value val or something that this value is the current value or something?
So this will be the current position of the iterator.
Yes.
Correct. So that is important. Since the iterator is traveling through the collection, so it is something which is traveling through the collection, right? So therefore, the iterator.remove will remove the element which is kind of the current position, not the current. Basically, it is just one before the current, which is essentially means, by definition, if you go, the remove method will remove that element which was last read by the next function call. So I told you this next will read the next element, right? So whatever value is read by this next at last, so whatever value will be read by the last next method call, that one will be removed by the remove method call. So the next which is nearest to the remove and just before the remove. So nearest and before the remove method call, whichever next method is there, and the data read by that next method will be deleted. You can also say that it is the current position, but it is actually not the current position. It is just one position before, or you can say just.
So is it the position where the flag is false?
No. That is see, flag can be for, even if I do not have these flag things and all, right? Even if I just write, let's say something like this, outside all of these I write itr dot next. itr dot, what's happening to my keyboard? Yeah, itr dot next. I can write something like this, okay, and then I can write itr dot remove. So this is perfectly fine. What it will remove? The itr dot remove will remove the value which is being read by itr dot next. Forget about that flag, if, for while loop, forget about everything else. Even if I write directly itr dot next and then write itr dot remove, then it will remove the item which is all just read by the last next method. Okay, so if I again write itr dot remove, then what will happen?
Error.
Correct. So this is important. So since remove method removes the element which was last read by the next method, therefore if I write two consecutive remove, what will happen? Already the element that the first remove has removed, that element is basically the next element, right? The element which was read by the last next method call. But now again I'm writing remove. Now for this remove also the definition is same. Remove means remove the element which was read by the last next method. Now for this remove element, the last next method is this one, and for this remove element also the last next method is this one, right? So but this element will be deleted when I am writing itr.remove here. Again, if I write itr.remove, then basically it will give an exception because no such element will exist at that point. So if you see the definition, it also says the removes from the underlying collection the last element returned by this iterator, right? This method can be called only once per call to next. So this line is very important. This method can be called only once per call to next.
Sir, could you please repeat what you said?
So I was saying that, let's say in the code itself over here, itr.remove will remove the element which was last generated by or read by the last next method. That was the scenario. Now if I come over here and outside I write itr.next, right? So this will read a particular value from the linked list, right? And then let's say I store this itr.next in some integer value. Right? This is fine. Now after this I write itr.remove. So this itr.remove, what it will do, it will remove the element which was last read by the next function call. So whatever value was there inside the, the y value, right? This I am storing it y inside this y variable, but basically this y variable is also the corresponding value is there inside the linked list, right? So that I accessed using the next method. So when I after writing itr.remove, that value will be removed from the linked list, right? Because remove function will remove the element last read by the next method. But if after this again I write itr remove, now again for the second remove also the definition is still same, that it will remove the element which is last read by the next method. But the value which was last read by the next method is already removed by the first remove statement, right?
So two consecutive removes will give an error. If
Error.
there is a dot next between these two, then it will be fine.
Then it will be fine. Then again it will get another item to remove because I am using the dot next method, right? So then it is a completely valid code. So the first itr remove will remove the element read by the first dot next method. The second itr remove will remove the element read by the second itr dot next method. But if I write consecutive without the next method, then this will generate a runtime error. Now it is fine, but later when the second remove will come in the runtime, it will see that no element is there to remove. So then it will generate a error of underflow. Okay.
Sir,
fine.
so for removing an element, if we use this iterator, then it will work fine, right?
Correct. Removing or adding, where the structure is changing basically.
But whereas if we use the for loop, it is throwing an error.
Correct.
So how this one works, sir? Like when we use iterator, it is able to like keep like the
why the error is not thrown in this case? What did I tell you in the previous case? Internally, everything is done by iterator. Even when you are running this for loop now, whenever you are running this for loop, then also internally iterator is only working. Only you are not using it because this for loop is more, visually it is more easy to understand for us. But if you have to use iterator, then one variable you are defining, then you are has next, then remove. These are not that much easily, not that pleasable for programmers. But internally, the iterator is only working in for loop also. That I'm not looking behind the scene, right? But now the thing is, in the for loop case, the iterator is working behind the scene, but the remove method that I'm using, that remove method is of linked list class, right? See, the definition is different. Here I have to provide the index in this remove method, but in this remove method I did not have to provide an index. Here I have directly written remove. So these two remove methods are different. They are not of the same class. This remove method is of iterator's remove methods. If you see the definition, what is it coming? Java.util.iterator public default void remove without any parameter. So this is java.util.iterator's remove method. But if I go to this remove method, let's say what is it coming? Java.util.list. What was it coming for the earlier one? Java.util.iterator.
Index.
Right? Iterator, yeah, iterator. So here you are providing the int index, that is one thing, but this is more important. Here it is defined inside the list class, this remove method. And this remove method, although the name is same, but this is defined inside the iterator class. Both of them are different remove. Okay, now let me comment it out, but again it will, otherwise it will again generate error. Okay, now the thing is, this remove method, I told you the only problem is happening not because you are changing the structure, but because you are changing the structure and somehow the iterator is not getting information about it. You are using the iterator internally behind the scenes by the for loop, but you are removing an element, you are not informing the iterator. That was the main problem. So how to deal with that? How to inform the iterator? Seems like we do not have any way to inform the iterator using some function call or something. We have to do the code using an iterator. So that's why we defined an iterator and wrote the code using an iterator kind of functionality. And now since this remove method is iterator's remove method only, this is not linked list remove method. This is iterators remove method. So therefore, this remove method, since it is iterators remove method itself, it will inform the iterator internally that, okay, I am removing one element, you keep your mod count one less. So basically decrease your mod count. The size will get decreased by 1. So if you go to the, I am not going into the definition of iterator remove method, but I think I briefly did that in the code walkthrough session. So yeah, in the iterators remove method, it will change the mod count value of the iterator internally. Mod count means basically the size, that how many elements are left to traverse through the collection. So, but the linked list remove method was not taking care of these things internally. Okay, so therefore, in that case, it was generating an exception. In this case, it will not generate an exception because here the iterator is well aware before going into the next iteration that, okay, one element has been removed from my collection. And therefore,
So
I have, yeah.
So even for array list, it will throw an error if you don't use iterator and remove.
Array list also, most probably array, yeah, you can check that. Actually, I have done the code using linked list only. If you check that using array list, let us see. By the way, array list, it is not that much problematic because array list remove does not work in the same way, but let us see how internal implementation is there. So it might.
So it will also throw same errors.
Yeah, so I also, because internally at the end of the day, it is also list only. So a list, right? Let me just change this to a list. Or I can just change the linked list to, I think this is better.
By indirection like this.
By indirection. See, nothing, no other problem. Everything I will keep same. Just only one place I changed and everything still works. Right? Yeah, so now we are using an array list. Yeah, so let us see. The name of the exception has changed, but I think this is for the same. Oh yeah, concurrent modification only. Sorry, not the name has also yet not changed. But yeah, the reasons are a little bit different. Co-modification. Yeah, so this is the term I was thinking. This is called co-modification. Check for co-modification in array list. Right. So yeah, so anyway, it is also creating the same problem.
Okay, what is the co-modification?
Same thing. Basically, you are modifying two things at the same time. The term used is just like that. Okay, so keep this concept in mind. If you are physically changing the structure, then you have to, in whatever collection, then you have to use iterator. You cannot work with simple for loop. Fine. So now we will come to another very, very important aspect. That is sorting. Not important aspect is not the sorting part. The important aspect is something else. We'll come to that. But in order to display that thing, we need to use the sorting functionality. So now let's say we have this array list of these fighters. Any UFC fan over here? Any one of you know these names, familiar with these names, which I have used for example? No one. Great. Fine. So by the way, these are real UFC fighters. So if any of you is interested in Ultimate Fighting Championship, you can see that. So these are the fighters or players who play in this UFC games. Anyways, so we have this array list of fighters. Okay, and I have these names and their corresponding number of matches they have won. Okay. Now, what I want to do is I want to sort this element. I mean, this array list. I want to sort this array list. Just a second. I want to sort this array list of fighters on the basis of the number of wins. Now you see, it's not that simple because here the array list is storing fighter objects. It's not a number value which will automatically be sorted, right? Or maybe which is easy to sort. So we have to do something about because this is non-trivial. It is not numeric value that you can just call a function dot sort and that sort function will understand that, okay, you want to sort a set of double value or set of numeric integral value and it will sort it accordingly. No, it is not that simple. It is a set of objects that you are talking about. Now I don't know what is the general way to sort a object, right? So there must be some condition, and that condition is you are putting that condition that I want to sort this object on the basis of the number of wins. Fine, but somehow you need to inform this to the Java system, or you have to write a sort method explicitly. So two options: either you can write the sort method explicitly, or you need to somehow mention the condition of sorting. So by using the completely writing from scratch a sort function, that is also fine, you can do that, but it will take a lot of time. So what we are using is, we have this collections.sort. Now what is collections? Collections is a class. Okay. Please pay attention when you are actually seeing the structure. If I write collection, right, it is coming error because sort collection.sort, nothing, there is nothing like collection.sort, that's why. But collection is an interface. Okay, collection is an interface of Java. Just when I add an S over here, then it becomes a class. Okay, so just if I show you like this, collection, you see java.util.collection, it is public interface collection, it is an interface. Okay, but if I add S over here, so Java util public class collections extend object. So this is a class. So
That is some other collection.
that is something else. That is a class and that is a collection. A collection is an interface and collections with an S is a class. Why this is important is many of us actually write collection.sort and the code doesn't work and we don't understand where is the trouble. Just because of one S, you are looking at somewhere else in your code, you are not understanding what's happening, but just because of one S silly mistake, it's not working. And sometimes it might so happen that you will not understand what is the error by looking at the log files, or not log files, what I mean is the error code which is getting generated on the screen in the console. It might not always tell you what is the problem. I mean, it will tell you, but many of times it so happens that you will not understand by reading it exactly what is the error. So please be careful about it. Collections and collection, both of them are there in Java. Collection without an S is an interface. Collections with an S is a class. And the sort function that we will work with deals with the collections class. So it is collections.sort, not collection.sort. Right? So here I am writing collection.sort fighters. But again, now you will say that just before now you said that this is not a trivial comparison or trivial sorting. So then if I am just using a pre-written sort function without writing my own from scratch sort function, then how will it understand the custom condition that I want on the basis of which this object should be sorted, right? So therefore the answer to this, we will come to that, but this is one way. Without writing your whole sort function from scratch, you can work, right? You can use this collections.sort and you can write the array list or collection name inside the sort function. But in order to mention the custom condition that I want the sorting to be done on the basis of number of wins only, you have to do something. Now what is that something? So you see the sort function, if I go in that sort function definition, what does it say? Public static T extends comparable. Now this is the comparables interfaces generic, any wildcard which is super type of T. So forget about, if you just give some time, you will understand what are these generics are doing. Okay, but what's important over here is this comparable. What is this comparable thing? So I'm showing you the sort function's declaration. This is sort function. What is this comparable all about? Right? So you see the sorts the specified list into ascending order according to the natural ordering of its element. So natural ordering would work when the values are integral, double, numerical value. All elements in the list must implement the comparable interface. So comparable is basically an interface which is already predefined inside Java. So if comparable is an interface, can we go and see the definition of that? Let us do that. Oh, it is, sorry. Let us. let me just go to the code. It is not working like that. So yeah. So see, oh, it is in java.lang, not in java.util. Anyways, so you have this comparable interface. Let us go to the definition and let me show you this at first. The public interface comparable. So this is a interface which is already pre-written inside Java. Okay. And what does this interface have? These are all commented parts. That's it. This is the end. Here the interface is getting closed. Only one function declaration, prototype. Okay, public int compared to. Fine. So you have this compared to method is there, which is only a declaration is given. Only one method is given inside this comparable interface. So when I am implementing, when I am implementing this class fighter, right? When I was creating this class fighter, since now I want to have a custom condition on the basis of which fighter objects should be compared, therefore I will implement the comparable fighter interface. I mean, not fighter, basically comparable interface. And since this comparable will work with fighter objects, therefore in the generic type I am providing fighter. Okay. So comparable fighter. Now, since I am now implementing this interface, I have to override the compared to method that we just saw. So here I am overriding the compared to method. Public int compared to, and inside the compared to method I am passing the fighter object, because that is the syntax. One fighter object we will pass, and this object, the fighter object that we will pass, this object will be compared with the current object. Current object means this object. I mean, this means this pointer I am talking about, right? So since, see, the compared to is also a method of the class fighter now. At this point, since compared to is defined inside the fighter class, that means compared to is also a method of fighter class. So that means compared to will be accessed by a fighter object. So basically I will write something like this after this. I mean, let's take some public void fun, some random method. Inside this method I might write fighter is equal to new fighter, right? Oh, let's say name is okay, and wins is, let's say 67, whatever. So we have a constructor and a new fighter object s, okay, and then I can write s dot compared to. Right, I can write something like this. Forget this. This is not s. I can use the compared to method, but then again, this it is giving error because I have one fighter object. So I can write something like this. So you see, the compared to method will be accessed by one object of the fighter class, and one object I will provide in the parameter. Now both of these objects will be compared and the result will be provided. Okay, and how will this work? See, let us go to the definition of compared to, what it says. The compares the objects with the specified object for order. So basically it will compare two objects. One is the calling object, which is basically using the compared to method to call the which is calling the compared to method, and one is the parameter object, which is passed in the parameter. Then it is saying returns a negative integer, 0 or a positive integer, as this object is less than, equal to, or greater than the specified object. So if this object means which object? The calling object, which has called the compared to function, right? So if this object is less than the parameter object, so whichever object is passed inside the parameter, if that object is more, that is this object is lesser than the parameter object, then it will return a negative value. I mean, you have to implement it so that it returns a negative value. This is a recommendation, right? You are overriding it. So since you are overriding it, the last decision is in your hand. Whatever way you want, you can operate with it. But this is the basic idea behind compared to. So this is a recommendation given to you that when you are overriding the compared to method, you should return a negative value when the this object is lesser than the parameter given, I mean this argument object, whatever object is given inside the argument. When this object is equal to the argument object, you return 0, and if this object is greater than the argument object, then you return something greater than one value. Okay, a positive value. So this is a recommendation. Again, I am saying this is a recommendation. Now, if this is the technique that you follow, then when you are sorting the array list, then that sorting, or not only array list, whatever collection you use, if you are using the collections.sort function, if you override the compared to method inside that particular class, I mean in case of this example, we were having a list of array list of fighter type object, and since the list was storing fighter type object and I want to sort that list of fighters, therefore I will override the compared to method by implementing the comparable interface in fighter class, because the array list was storing fighter objects and I want to sort that array list. So therefore I will implement the interface and override the compared to method inside fighter class. Inside fighter class, when I am overriding the compared to method, if I return a negative integer when this object is lesser, 0 when this object is equal to, and positive integer when this object is greater than the parameter object, then the sort function will sort the list in ascending order. Because by default the sorting happens in ascending order, right? I mean, if you guys are not aware of it, if you don't mention any explicit condition, by default any sorting condition, any sorting function will sort your data in ascending order. So this is the general idea for ascending order. So if you want your data to be sorted in ascending order, so this is what you should follow. Now, if I ask you that I want descending order, I want sorting on the basis of greatest value should be coming at first, then you have to reverse this recommendation. Then you have to change this recommendation to just the opposite. You return a negative integer when the this pointer is greater. You return a positive integer when the this pointer is smaller than the parameter object. Okay, so that's what we are doing. I am overriding the compared to method, and here I am returning obj.wins minus this.wins. Simple code, but please understand this. See, here I am using the wins variable only. So this is what you get. Unless and until I mention this, unless and until I override this compared to method, the sort function collections.sort was thinking, okay, these are some random objects. I don't know how to compare between them because they are non-trivial. There is no natural order to order these objects. But since now I have overridden the compared to method, internally sort function will always refer to the comparable interface. I showed you in the definition of sort function that it is working with the comparable interface. So it will go inside the comparable interface for fighter class and it will see, okay, that the compared to method is overridden. And what is the compared to method saying? It is saying that object.wins minus this.wins. Okay, so whatever value it will return, on the basis of that, the sorting will work. Okay, now you might ask that if I change this from object.wins minus this.wins to this.wins minus object.wins, so then what will happen? Just the sorting sequence will be alternated. So if it is sorting in descending order, there it will sort in ascending order. Right? If you just reverse these two things. If you just reverse these two things from obj.wins minus this.wins to this.wins minus obj.wins, then the sort function over here, where did it go? This sort function will sort the fighters in just the opposite order. Okay, fine. So yeah, so I am overriding the compared to method and everything else is same. This is just to show you guys, important. And here we are overriding the toString method. This is the fighter class. So in order to define the criteria on the basis of which I want sorting to be done, I have to implement the comparable interface in that particular class and I have to override the compared to method. Inside the overriding body, I have to mention on what field I want the comparison to be done or on what condition I want the comparison to be done. And if I want ascending order sorting, then I will return a negative value when this pointer is smaller and positive value when this pointer is larger than the parameter object. If I want descending in the opposite order, which is descending order of sorting, then I will return a positive value when the this pointer is smaller and the negative value when the this pointer is larger. Okay, so now in this example, I want to sort in descending order. So the person with maximum win will be shown at top. So if that is the case, the sorting I want is in descending order sorting. So therefore, I have to return, if this pointer is more, then I will return what value? Negative value, because here I will sort in descending order. So if this pointer is more in comparison, I will return the negative value. So here, here we have overridden using this line. So you see, if this pointer is greater, this dot win is greater, then what is happening? It will return a negative value, as you can see over here. Fine. So then we can run the code and see that it is working. Oh, I have not changed that to where is that?
So that array list.
Yeah. Just searching that. Oh. So you see here, the initial dictionary was something like this. Sorry, not dictionary, array list was something like this, 28, 29, 22, 27. But now I have sorted it as 29, 28, 27, 22, descending order. So this is the way how you sort objects where there is no natural ordering. This please be very familiar with this overriding the compared to method by implementing comparable interface, because this is a very common practice. Whenever you have to provide a custom condition on the basis of which you want sorting, and that will happen all the time, because it will be very less time that you will work with integral value. Most of the time it will be some object, and since it is an object, you have to implement this comparable interface in that class, and you have to override the compared to method on the basis of what field you want the comparison to happen. Okay, if I just reverse this, let us see this in example also. Rather than obj win, if I write this dot win minus obj dot wins, if I write something like this, so and then run the code again, now you see it will be in the other way. So this was the initial array list, right? Now you see it is in the ascending order, 22, 27, 28, 29. And in our previous course, it was 29, 28, 27, 22, descending order. Okay.
So when we write the sort fighters, it will first check whether we have, whether the fighter implements comparable. Otherwise,
Correct. I showed you, right? If you go to the sort definition, so you see public static t extends comparable. So this is the definition of the sort method, void sort, right? But you see here, comparable is given. So return type will be something which is of comparable type. And you see the definition also, sort the specified list on the basis of natural ordering, or if the natural ordering is not possible, all elements in the list must implement the comparable interface. Getting the point? So comparable interface has to be given. This implementation refers to the list dot. Okay, there is something else. Anyways, yeah. So the comparable interface must be overridden. If you want your custom condition, if it is a number value, integer value, then anyway sort will do it on the basis of natural ordering, as it is saying over here. Okay.
Yes,
so any doubt in this?
Sort will go one by one and check the first value and second value and find that to compare to, and whether it is negative, then it will replace, right?
Correct. If it is negative, yeah.
Yes. If it is positive, it will not do any change.
Correct. And if it is in the other way around, whatever, so that will happen upon the condition that you are using. If you are using a negative value, I mean, I told you, right? The compared to method, whatever value, if you are returning a negative value when this pointer is greater, so then it will do in a descending order. So by swapping each pair of element, it will check the compared to method and compare between those two objects, right? By calling it will implicitly call the compared to method internally. Okay, so the compared to method will be called internally implicitly. let me just check one thing. It is calling it implicitly, but let us, I don't think it will be printed, but unless and until we call it, okay, see what's happening.
Yes, sir.
So how many times it is calling? 1, 2, 3, 4, 5, 6 times.
Yes, sir. So there are
Why?
4 elements.
Yeah, so each pair you are doing, right? So whatever the condition is, first is maybe 28, 29 is comparing, 29, 22, 22, 27. So 3 times, then within the 2 things, 2 leftover 2 things. So again 2 times, 3 to 5, and then again 1 last time, 6 times. Right? How many ways you can do? 3 plus 2 plus 1, 6 times. 4 elements are there. First comparison will be 3 times, then 2 times, then 1 times.
Yes, sir. So first it compares the John and Khabib.
Yeah,
And
John and Khabib, then
then
Khabib and Daniel, then Daniel and Demetrius. After
no,
that,
this
whatever.
will be 28.
And then
And
after.
OBJ will be 29.
Correct.
OBJ wins.
Yeah. So see, this is how you understand. I am not using the compared to method. I am not calling the compared to method, but it is getting printed on the terminal that the compared to method is called 6 times. So that means internally the sort function is internally calling the compared to method multiple times to compare every pair of objects. Right? That also is properly observable. Since there are 4 items, we are calling in the first run to compare 3 objects, then comparing the leftover within the 3 object. First object will be sorted, right? We have 4 objects. In the first run, when I am comparing, one of the object will be, the greatest object will be found, and we will keep it aside. Right? Now, if you keep it aside, and how many comparison you need? 3 comparison. 4 objects are there, so 3 comparison. So with 3 comparison, you will find the greatest value. So you keep that greatest value aside. After that, still 3 values are left. 3 objects are left. Right? So within those 3 objects, how many comparison you will need? 2 comparison. Always 1 less comparison, right? So 2 comparison for 3 objects. So first you needed 3 comparison for 4 objects. You found the greatest object, kept it aside. Leftover with 3 objects. With those 3 objects, you do 2 comparison. So again 2 comparison. Now in this iteration, you again found the second highest object. So you keep it aside again. And then again you have 2 comparison to be done. 2 objects left over. On the basis of that, you do 1 more comparison. So 3 plus 2 plus 1, 5 comparison you have done, and now you have found all the objects in the sequence. Last 1 object is left. Now basically this is maybe one improvement Java could have done, that whenever the last object is left, I need not make a separate call for that. But anyways, somehow it is again calling that on the same object, and it is referring to itself and calling itself and then printing it to the same position. So that is the 6th call. So 3 plus 2 plus 1, 6 call. If it is for, let's say, if I would have increased 1 more object, 5 objects would have been there. Then I would have what? 4 plus 3 plus 2 plus 1. Right? So 7, 8, 9 and 1, 10 calls would be there. I assume 10 calls will be there. Okay.
Okay, so first 28, 29 compare and replace, right? Swap.
Correct. Selection. So I don't know you guys have done those things or not. Selection sort, there is one kind of sorting. So this kind of working like selection sort.
So this sort one uses which algorithm? Like selection sort.
I mean, so that is not required for this Java course, right? So internally, whatever sorting it is using, we don't have to worry about that. So, but I assume it is merge sort and quick sort, a combined manner. Depending upon what is the data size, it will do merge sort and quick sort with some conditions. You can check in the sort function, the definition you can understand. Okay, fine. We will not go into that as of now. I hope this comparable part and compared to method overriding the condition of compared to y this dot minus object dot y object dot minus this dot, using the field that I want on the basis of which the comparison will be done. All these things should be crystal clear. If you have any doubt in these aspects, ask. Anyone has doubt in these basic things? Basic things means these ideas that I discussed. Okay, internal implementation, don't worry about that now. Any doubt? No doubt.
No.
Yeah, go ahead, go ahead.
No.
Oh, no doubt. Acha, fine, great. Okay, these things you can see when the code is released. We have some interesting fact. If you want to check that out later, you guys can do that. So, anyways, this
So
codes
can
will.
you share the link of your codes?
I think these are already shared, right? Or isn't it shared? I mean, these are code walkthrough codes only. So I hope. Just a second. Uh, okay, supplementary content. Fine, I will. Yeah. Correct. Yeah, we will share it. It should have been shared by now. I was under the idea it is already shared. Okay, you see, so this is where I explain these things like iterable, collection, queue, list, array list, linked list, this collection, what is the structure, all those things are discussed. Fine, we will share the code. Okay. I will tell them tonight. Hopefully by tomorrow morning, you guys will get all the codes of from week 1 to week 6. Fine. So what I was telling is that this is some interesting fact. If some of you want to go through, I mean, not now, after your OPP, you can check these things. That we use this Fibonacci series as a recursive function, right? So there are different kinds of recursive functions. Some recursive functions are such that without using recursion, you cannot write them. So what I mean is Fibonacci series can also be calculated using loops, right? You can use recursion or you can use for loop. That also can be done. But there are some recursive function which cannot be written using for loops, like some fixed length for loops. You need some infinite kind of structure to write them. I mean, convert them into loop kind of fashion without using recursion. So they are a bit difficult to discuss. This is a theoretical computer science topic, but anyways, so there are some functions which are so heavily recursive that you cannot write them otherwise. You have to write them in a recursive kind of manner. So those are called your primitively recursive function. But anyway, so you guys can check that if some of you want that. And there is one function called Ackermann function. This is one of the fastest growing function. It grows more faster than your exponential or super exponential functions. Okay. Oh, yeah. Fine. So let us go to the next code. Okay. So we will now see the next set of data structures. Okay. And first thing is set. So I told you this set is another kind of data structure. And what is the primary feature of set? It does not allow duplicates. Okay. For your coding related perspective, understand this much. It does not allow duplicate. I mean, I'm saying it in this way because many of you, 50% of you are not aware of the internal data structure concepts. So there is a huge difference with respect to, I mean, not with respect to, what I mean is there is a lot of things other than in set, other than just that it removes duplicate, right? So don't think like it's just remove duplicate. Why are we going through so much trouble just to remove duplicate? So there are a lot of other things with respect to set operation. But for your perspective now, just understand it removes duplicate from coding perspective, because the other factors that it does that are primarily based upon the two things that I discussed earlier. First is time and space. So this hash set or tree set that we will talk about, they work with this time and space complexity in a very different way rather than list or linked list or array list or whatever, right? They are much more efficient than a normal linked list or an array list. But the only thing is we cannot discuss that within the scope of this course. So you will learn that when you see PDSA course. So there are a lot of different things with respect to set, but as of now, for your coding idea, just assume that what they do in the front end is, back end they may be very efficient, but front end what they do is they remove duplicate. So if you put multiple duplicate values in a set, it will not keep any duplicate within it. It will take the input and automatically silently it will remove the duplicates. So when later on you print the same set, it will show all the data without any duplicate values. Okay, so that is the basic understanding of what set does. So now we have two sets, S1, S2, up to both are integer type, and these are the two ways we can initialize a set. First is it is empty, we have not put any data. And second, in the initialization only we are putting some data, and that is by using this arrays.asList. In the constructor definition, I'm writing this arrays.asList, and then within asList I'm providing this value. This again A is added by the compiler. Okay, as soon as I put a bracket, it is not compiler, the ID. As soon as I put a bracket, it will add those A, right? Just, yeah. So this A is not assume that this A colon dot dot dot, these things are not there. Okay, just assume that these things, whatever these whole things are, this thing is not there. It's just added by the ID. Okay. Fine. So these are the values that I'm adding, 50 to 55 in the hash set using this asList method. So all these values are added in the hash set S2. In S1, what I am doing, S1 I am explicitly calling the Fibonacci function again, right, to add element, just like I added in linked list and array list in the previous class, in the previous program. Here also I'm using that Fibonacci function again to add the element. How to add? Again, here also the function is same, dot add. Nothing new. Again, here also it is dot add. One thing that might be new to you guys, that is this thing, java.2.datastructure.fib. What is happening? Fibonacci is defined in the other program, right? But how can I write something like this? So this is basically I'm locally importing the function which I wrote over there. Okay, just as of now, assume that this can be done, but this is not important for your OPP also. You can just define a Fibonacci method in this program itself, right? But I was a little bit lazy, and so I kind of imported it over here. The same Fibonacci function I defined in the other previous program. So you can just know as of now that you can do this kind of stuff, right? That you have written it somewhere else and you are importing it and using it in some other program.
So above you have imported java2.datastructure.
Sorry, please repeat.
No, have you imported java2.datastructure anywhere above, or?
You don't need to do that, because Java 2 is basically one of the primary packages that I have, and .data structure is a public class, so I can do that. So these things will be clear. You don't have to import that actually. Okay, you can directly write it in this manner, provided that some rules are followed while defining the data structure class. Yeah. So those rules and those things will be discussed in subsequent weeks. So don't bother about that. Okay, as of now, just assume that there is one Fibonacci function within this program only. Forget about this whole line and assume the Fib function is within this program only. We will discuss when you see that these packages, right? You see the packages week, we will understand all of these things in detail. Fine. So as of now, just think that we are adding using some function which is generating a value. You can also put some static value like 10, 20, 30, 40, whatever. Some value, the add function simply add the integer or string or whatever value you give inside it, the add function will add it into the set. Okay. So set, hash set. I told you there are two kinds of set and two kinds of map. Hash set, tree set, hash map, tree map. And the reference variable are set and map. It is better to use. You can use hash set, tree set, reference variable too. But for the obvious reason we discussed in the previous code, it is better to use reference variable like set. But anyways, you can also use hash set and tree set reference variable also, no problem. Because sometimes you might need functions which is only defined for hash set and tree set. So in that case, since it is not overriding, it is better to use in that kind of situation the tree set reference variable or hash set reference variable, because non-overridden method are done compile time binding, right? So some methods you might not get when you are using set as the reference variable. You have to define hash set only, right? So let's take an example what I mean. So if I write S1 and then write a dot, please try to remember these functions. Add is there, add all is there. Contains, contains all, equals, for each, get class, all these things are there. remove if, remove all, split, stream, wait, and that's it. Contains, okay, kind of these things are there. But if I write it as set, not set, but if I write tree set or hash set, whatever, this hash set, right? So hash set. Now if I write s1 dot add all, clear, clone, contains all, for each, get class, iterator was there in the earlier one. There, anyways, let me do it parallelly, it will be better. That is done. So s3 dot s1 dot, okay, s3 dot, what am I getting? Kind of similar only, there is not a difference in case of this. Yeah, kind of similar. So yeah, not much difference in case of set as an example, but maybe in some cases, some other data structure, it might so happen. What I mean is, sometimes while using a reference variable of a super type like set, right? Set is here a super type reference variable. The concrete class is hash set, right? So when you are not worried about changing data structure or writing packages or importing code from other, all these things are not there. For example, your OPP, you don't have to worry about all of these, right? You just have to finish your code. So in such situation, I would recommend, see, programming from a programming point of view, programming practices point of view, using an interface type indirection is much better, and we saw the reason. But for your OPP perspective, using a concrete class reference variable might be better in situations, because in case of hash set and set, it did not occur, but in case of some data structure or collection, it might occur that some functions are only defined inside the concrete class itself, and their prototype or their declaration is not defined inside the interface, right? So here inside set, I mean, let's say inside set, a particular inset interface, no, sorry, what I mean is, let's say inside the hash set class, one particular method is declared and defined for the first time, which is very particular to hash set. So that has no meaning when it is defined as a part of set interface, but it only applies to hash set. And that's why it is defined inside hash set class, right? Maybe the property, maybe the working of that function is such that it is only applicable for hash set. So then it will work for hash set, but it does not hold any meaning when it is defined inside set interface. So that's why it is not defined inside set interface. And now you need to use that method as a part of your code. And you are writing something like this line of code, line number 8, set s1 equal to new hash set. Now we have told you to use a interface type reference is much better in coding practices. So you write it like this, but now you are writing s1 dot, you want to use that function and it is not showing that function. And it will not allow you to use that function which is defined inside hash set. Why? Because that function is only defined inside hash set class. It is not defined inside it is not declared inside the set interface. So you will not get that function. Okay, so from your OPP perspective, since now you will mostly use different kinds of function to write collections code, it is better to use concrete class. But for your understanding purpose, unless and until you absolutely need a function which is only defined inside a concrete class, it is always better to use a upper type of reference variable, a reference, interface or superclass reference variable. Okay, fine. So we have this,
that error
Go ahead. What are you telling?
Some functions may not be defined in set, so it will throw error. So how do we
It
counter
will
that?
not, you will not, there is no error. It will not show you anything. I mean, you cannot use that. If you write, let's say set integer s1 equal to new has set, like in line number 8, and then you write s1 dot, that function will not show itself. That you cannot write that function. It will not, I mean, if you write forcefully, it will create error. Yeah, compile time error it will show. So you cannot solve it. There is no way to solve it. You cannot do it because in that kind of situation where you need to use a, such a function which is only there inside the concrete class, in such a situation, you have to use a reference of concrete class. There is no workaround for that. Okay.
Or we can't typecast because it is pointing to an object of hash set. If we
You can
typecast
do, yeah, you can do typecasting. That you can do by forcefully converting it into a type, and then you can do the dot. Yeah, that you can do. Typecasting can be done, but yeah, then again, yeah. So these are programming practices, right? If I tell you now, typecasting is not a very good idea because again, for that is for your programming, normal generic programming perspective. If you're writing for OPP or for some competitive coding part, you will use the concrete class reference only. You don't have to worry about all of that. But if you are writing code for your enterprise level software, then typecasting is again not a very good option. I mean, because typecasting creates a lot of problem in production sometimes. So it is again something which is not always appreciated. So rather than that, using a concrete class definition is much more better. Okay, typecasting is not always good. I mean, but these are all programming, enterprise programming paradigms. You don't have to worry about all of this now. Simply speaking, for your coding exam and OPP and all of these things, just assume that define the concrete method, define the concrete class reference variable if you need such a specific method. If you do not need such a specific method, use interface type reference. Fine. So now, okay, now we have created a hash set and we will add it using s1.add, nothing new. We are adding some other values also, 8 and 13. So see, I have added duplicate values over here. Why? Because Fibonacci number is what? If I write the Fibonacci number 0, 1, 1, sorry, right? 2, 3, 5, 8, what after that? 13. 21, right? These are what the Fibonacci numbers are. So 8 and 13 are already put inside the set, and later here again in line number 14 I am again putting 8 and 13 into the set, right? And then I am S1 after adding duplicates, then I am printing S1. So see what happens. So initially S1 was this, okay. See, it is not sorted. 0, 1, 2, 34. See, one beautiful thing over here. Where is that? Yeah. You see, this for loop, it is adding the Fibonacci numbers from 1 to 10, one by one, right? So first of all, the first number will be added, that is 0. Secondly, the second Fibonacci number will be added, that is 1. Third, the third Fibonacci number. So everything will be added in sequence. So 0, 1, 1, 2, 3, 5, 8, 13, 21, dot, dot, dot. So this should have been the sequence in which the element should be there inside the set. But here I am printing the value of what is there inside the set, and it is showing me in a random manner. It is showing 0, 1, 2 is fine, but then it is showing me 34. 34 is coming even after 21. Then it is showing 3. So what is happening? There it is
no
showing 5.
order.
No order. So this is another very important point of hash set. I told you already, hash set does not sort. It only represents the element and it removes the duplicate. Tree set will do the sorting. But another important observation over here is not only hash set does not sort, but also it does not obey the sequence in which you have entered number in the hash set. Not, I mean, sort to wo karega hi nahi, it will not sort at all, but on top of that, it will not also follow the sequence in which data has been put inside it. Okay, so that also hash set will not follow. It will do it on its own mind, however it wants. It will keep the elements in that way. Okay, but it will remove the duplicate. As you can see here, one was given 2 times in Fibonacci number, but in the first case only one is given only 1 time. So one has been removed. Then I am adding system, this 8 and 13 were added 2 times over here, right? Because 8 and 13 were already there in the S1. So after adding duplicates, still you see 8 and 13 is still same. See here, no error was generated. The code has run. So no error or no exception will be generated. Everything will work. Only thing is it will silently remove the duplicates. Okay, so then we have this add all method. I mean, there are many such methods. These things you have to practice and understand. Add all is there, so it will basically join 2 sets. So S1 dot add all S2 means join the contents of set S1 and S2. And then there is contents method. So this is used for searching that whether the particular set I'm talking about, whether that set has these 100 value present inside it or not. So you can use the contents method. S1 dot contains 100. If it contains 100, it will return true. Otherwise, it will return false. Okay. So these are some questions. Why another data structure just for checking if present or not? That's what I'm saying. So this contains, you might think, okay, so linked list, array list, we could have also run a loop and find out an element. I mean, or maybe we could have defined a function of find or something like that. So why we are using this set to do this simple thing? So that's what I'm saying. The operation time for linked list will be very much higher than operation time of finding an element into a set. Okay, so we have now seen hash set. Now we will see tree set. Same thing, no difference. Removes the element, duplicate element. Only difference is it will implicitly sort. Observe over here, we are not using collections.sort or any other sort function. Tree set's property is this, that it will sort the element automatically. Okay, so and it will also remove the element, like hash set was removing the element automatically. Tree set will also remove the element automatically, but it will also keep the element in a sorted fashion. So here if you see, I have 99, 67, 99 again repeated, so this 99 will be removed. 178, 12, 67 is again repeated, so this 67 will be removed automatically. So then whatever are the elements, these 99, 67, 12 and 178. So these 4 elements will be internally, sorted automatically inside the tree set and presented to you in the sorted manner. Okay, fine. And then we have this contains method, add all method to join true tree sets. Okay, contains will return true if it contains 13. Nothing new. So everything is same, just like hash set only, just the sortedness is there. Actually, not everything is same. There are a lot of different things, but those are some data structure point of view, timing point of view, space point of view.
Wherever, means anywhere, do we mention root node, means value of the root node or something like that in this?
No.
In this code, I mean.
Why root node means which node are you talking about?
So tree, normally it will be a binary tree, right?
Forget
So
about all of that. Forget about
Achha.
all of that.
Okay.
Forget completely. I don't want to go into any of those details now, because if I go into those details, it will be a completely separate session. What is root node? Okay, just from your coding perspective, because you guys have your OPP in 2019, I think, right? Yeah, 19. From that perspective, you just have to focus on the functionality. Internally, don't waste your time in thinking how it is that वो सब करना 20 के बाद. And for those who are aware of these things, how internally, what is a tree, what is all these things, those guys can refer all of that. But for others, I don't want to go into these details in this session. Okay, yeah, obviously there will be root node. Obviously it will traverse through on the basis of whether I have to go left or go right. It will be login search complexity. But if I go into discussing all those things, it will take time. So
no, I'm not asking the explanation. I'm saying that in code where we have to mention that.
You don't have to mention that. Why are you worried about? So let's say whenever you are writing a tree also, okay, so you have written a complete tree structure and done everything. So when you add into the tree, right, you have defined the method add. When you are writing the method add, right, so then you have to think about what is the root node, what is the size, all those things you think about that, go left, go right. But once you have written the add method, when you are adding a new element, at that time you don't have to worry about it. You just write dot add whatever, whatever is your object name, object dot add, and then you write the value which you want to add. Do you mention
Yeah,
root
got
node
it,
over there?
got it.
You do not mention, right? Because all those things are done automatically. Whatever is the first element added, you will in the add method, since you are asking, I'm telling you, in the add method where you have defined the add method for the tree, there you will have a check first if condition in the add method. If size equal to null, if the size is null, then that means there are no element in the node, and that add method is called, that means it is basically called to add a new element. And if size equal to null has become true inside the add method, that means a new element is going to be added, and that's why I am being called, I being the add method here, I am being called, and my condition of if size equal to true null has been satisfied. That means there are no elements, and then the element which is currently coming in is the first element of the tree. So that's why what will I do? Root equal to current
What
element,
it minimum heap method it uses, yeah. Okay.
right? Yeah, minimum heap or whatever, even if you consider it as a tree, your whenever the size is null, you will set the root node to the current element, and then whenever you are adding new element, then you will just keep the root node as fixed and modify all the other whatever other pointers you have, left pointer, right pointer, whatever. So anyways, so the root node, you don't have to worry about that, because once you have defined the add method, all those things are taken care of inside the add method. By the way, this is not heap. This is, since you mentioned, I'm telling, this is not heap. This is normal tree only. Okay. So yeah, here min heap is not used. Min heapify, nothing like that is working over here. We are only working on the basis of simple addition in binary trees. Binary search tree, not binary tree, because tree set is basically implemented internally like a binary search tree. Okay. So anyways, coming back to our topic, hash set and tree set, two things. Important thing for you as of now is hash set removes duplicate, does not maintain order. Okay. And yeah, we have this method like contains, where you want to check whether the hash set has some value or not. And in order to add elements, you use the add method. Tree set, only difference is it keeps the data in a sorted fashion, everything else is still same. So if let me just show you the output of tree set. You see, what was the, just a second, I forgot to write the tree set. Oh, TS2 is there, right? Okay, TS2, tree set 2. So you see TS2, 12, 67, 99, 178. So I had 67 and 99 two times, if I remember correctly. Yeah, 99 and 67 were here also, and 99 here also, and here also 67. So only one time it is there, automatically it is removed. Only one time each of the numbers are there, and when I'm merging these values, then also all the numbers are uniquely merged. Those numbers which are twice, all of them are removed, right? Yeah, nothing new. Okay,
Sir, what is S1, sir?
What is, sorry?
S1.
S1. Where is S1?
For
Oh,
TS1.
this is my the link, the initial hash set, tree set, that, yeah, the hash set that we talked about. This hash set, S1 is the hash set.
Okay.
So this is only one output. I have written the whole code, right? Okay, so now it is again more difficult. Okay, so there is another concept of queue and stack. This is again something new for those who don't know. What is LIFO, FIFO, last in, first out, first in, first out? How to do it? I don't know. Okay, anyways, I will just go ahead with it normally. So basically there are two other, so we talked about linked list, right? So we talked about linked list. Now linked list, as I told you, that you can assume that there are multiple nodes like this in linked list, which are kind of array only. The way the numbers are values are stored in linked list is kind of array. Only difference is it is non-contiguous. Now a linked list can be implemented as a stack or a queue. As a stack or a queue. Now what is a stack? What is a queue? The thing is, in a linked list, normally if I talk about a linked list, right, implemented as a queue, linked list as a queue. In such a situation, I put some constraints. What is the constraint? That on this linked list, which I already had, I put a constraint that you can only add element from the backside and remove element from the front. Fine. So you cannot add an element in the front. You have to remove from front and add at the backside. Backside means, let us say the first element that was entered in the linked list was, let's say over here I am drawing, the first element that was entered was, let's say 12. Okay, so I put a box and make a 12. Then let's say 20 was entered. So I will write 20 over here. Then let's say 13 was entered. So I will write 13 over here. Then I want, let's say 46 to be entered in front. So I want 46 to be here. So if you have done it in the basis, I mean, if you have implemented the linked list as a queue, then this is not allowed. You cannot insert in front. You have to insert at the back. Okay. So basically, now I have to insert 46 over here. So linked list implemented as a queue will put this restriction that you can only do insertion at the backside. Okay. Acha. Linked list insertion at back, removal from front. Linked list as a stack. So this is what we call first in, first out. Why? Because as you can see, the first element which has, I told you, the first element which has entered was, let's say 12, then let's say 20, then let's say 24, then let's say I wanted 46 over here, but I told you that in the front you cannot insert, so therefore 46 is also inserted over here. So, and I told you the removal of element. Now if I want to delete and I want delete 46, cannot delete, you cannot delete 46. In case of queue, okay, when linked list is implemented as a queue, you cannot delete 46, you cannot delete 24, you cannot delete 20. As long as 12 is there, you cannot delete anything else. If you want to delete, you can only delete 12. So deletion will only happen in front. Okay. So I can remove 12 at first. So 12 is removed. 12 is removed at first. So you see 12 was entered at first and it is also getting removed at first. Therefore, first in, first out. Whoever has come in first is going out first. Okay, now linked list is implemented as a stack. How it works? So let us see that. So this is my usual linked list again, coming back to the usual linked list. So in such a situation, in case of a stack, what will happen? We call last in, first out. So suppose this is the front, okay, this is the front of the linked list, linked list implemented as a stack. So let's say I add an element. So now in this case, when you are implementing as a stack, you can do it on either end. You can do it in the front end also, you can do it in the back end also. Okay, doing it means, what do I mean by this it? So what does last in, first out means? So whichever has come last will go out first. So if I've inserted so when I want to delete something, I will delete the value which has came in last. That means what? Which has came in latest. So the latest value which I have entered, that is the value that I will delete first. Then only I can delete some older values. So the recent value will be deleted first and all the older values will be deleted after that. And in case of a queue, what was happening? The oldest value was getting deleted at first and sequentially the little less older, then a little lesser older, then more younger, then the latest element was getting deleted at last. Okay, but in stack, the other thing will happen, opposite thing will happen. The latest element will be deleted at first and then a little bit older element will be deleted, then a more older element will be deleted, something like that. So basically in whichever end I will insert value, from that end only I have to delete the value, because I am inserting that value means that is the latest element and that is the end I will delete also. So therefore I can do it either in front or either in back. It does not make a lot of difference. So for this example, I will take just, let's say I will add the element in front. So let's say I add the element 36 in front. If I have to delete, then let's say I add 12. Now if I want to delete 36, I cannot do that. Okay, because last element that came in is 12. So the first element that will came out is 12. So therefore I have to remove 12 at first. Once I have removed 12, 12 is no longer there in the this array linked list. After that only I can remove 36. Okay, so this is called linked list as a stack. Now you could have also done it backside also. So let's say I enter 36 before. Same thing, nothing different. I will not. Okay, so anyways, 36 is there. 12 I enter, then 12 has to be deleted at first. Then only 36 can be deleted. So last in first out philosophy, if it is followed on a linked list, the linked list is called stack. First in first out philosophy is followed on the linked list, then the linked list is called queue. If neither of this philosophy is followed, you are entering from one side, deleting from other side, deleting from the same side in the next iteration, then you are not making it either a stack or a queue. It is basically a random linked list in which you can do anything. Okay, so that is not a stack, neither a queue. It is a normal random linked list. Okay, so there is a third category to all of this.
DQ.
Yeah. So there is a third category, and that is not something very interesting. But anyway, so the third category is so the linked list as DQ. Okay. Now, what does a DQ means? So DQ means, or many people call it DEC, whatever. I don't know what is correct, whether it is DEC or whether it is DQ. It is called doubly ended queue. Fine, doubly ended queue. So that means, what was queue saying? You can add here, remove here. Assuming this is the front side, this is the rear side. Okay. So this is the rule of normal linked list as a queue. In DQ, you can do the addition and removal on both the side. So you can add here also, you can remove from here also. And you can, here remove is already there, you can add also. Okay, so both the end offers you both addition and removal of elements. So that is what we call a DQ. Okay, now since collection framework has already all the implemented methods and all these things given to you, so you only need to understand the concept and use the appropriate method. So we will see the example of a DQ. Okay, because you see, if the DQ is, we have worked with DQ, then that means I have the power to add and delete on both the ends. Now, according to my code, whatever I want to achieve in the code, right? Let's say I want in some features you will need stack, in some code you will need queue. So whatever it is, I will use the appropriate method, and then using that I will operate upon the data structures or collection, either on backside or on the front side. So therefore, we will learn the queue. So you see, these are the, therefore I am using this linked list class. Why? Because basically I told you, linked list is the class which is used, which we are using as stack, linked list, I mean stack, queue, or DQ or DEC, right? So basically, if I have the linked list class, then I can use all of the, I mean, all the methods, all the things that I want. By the way, okay. Anyways, so therefore, I am using the linked list class as an example to work with all this kind of data structure, basically stack, queue, or DQ. Okay, so here I have used linked list integer, this as list function we have already seen. And then we are adding some, showing some method. So this add first, the see. So here we are using add first. As I told you, first means in the front and last means at the last. So I have already discussed, you can add and remove on both ends. So this is adding at the front end, this is adding at the rear end. This is removing from the first end, this is removing from the rear end. Okay. Also, you can, since linked list is the object, I told you queue is an interface. So you can have a queue interface to a linked list object. Nothing different, same thing. Okay. You could have also, so this is what I'm saying, you can also write deck, right? Because ultimately linked list is the concrete class. And you can write that concrete class. I mean, I told you, right? So all these things are implemented. So see, linked list as a stack, linked list as a queue, linked list as a deck. So this as a thing is there. So whatever as a is there, I am not worried. When I'm defining the instance variable, I need the concrete class. So therefore, I'm using the linked list. So keep this thing in mind. When you have to write a stack, when you have to write a queue, when you have to write a dequeue, always use this new linked list. Okay, fine. So if you write the reference variable to be queue, no problem. If you write the reference variable to be dequeue, no problem. But linked list should be there. Okay. Now there are some methods of this. Now we have taken this queue interface variable and then we are using it. Okay. So there are some methods, new methods we will learn, which is basically offer. Which is basically offer. Now what is this offer? Add we already know. Essentially it is linked list, right? I told you this linked list. So linked list add we already know. Okay. Then we will see this queue.offer. Now why we are coming to a new method called queue.offer? We already, by the way, what is offer doing? Offer is simply adding 90 into the linked list. I mean, in this case, it is implemented as a queue because you can see queue is over here. I have this queue thing, right? Queue interface is there. But anyways, so queue interface, therefore I'm using this queue.offer method. Offer method will simply put the value 90 into the linked list, which you are implementing as a queue, right? Yeah, so it will do that. But then add was also doing that. Queue.add was also working. Linked list's normal add, that also was working. So why we are coming for a new offer method? The reason for that is, in some situation, your exception can be generated by the add method. In what kind of situation? When you have a bounded data structure. So we are not going into that because we have shown an example, not shown, I mentioned an example over here. So some lists are there which are basically, I mean, you can set a limit to it. You can say that this is the length. So if there is a fixed length, like array blocking queue is there. So while you define array blocking queue, you have to mention the length of the array blocking queue, that this is the maximum number of elements inside the queue that we are defining. Just like you need to mention the length when you are defining an array. Here also in array blocking queue, you have to mention the length. So when you have already mentioned the length, in such a situation, if you add a number after the size is full, then an exception will be generated. Right? That will happen. But if you use the offer method, then even if the size is full, no exception will be generated. The code will not block. The code will proceed through. Only thing is the function will be ignored. So 90 will not be added, but the code will go ahead. Okay. So, but the only thing is you cannot do this offer for all types of collections. You can only do this for queues, right? So therefore we have the reference variable as queue. So queue.offer is something which, which kind of bypasses the exception in case of overflow. Peak is just simply it will return whatever is the front element, it will return that value. Okay. Add all you guys know already. Poll. Now we are learning another new method which is poll. This is just like offer is for add, poll is for remove. Like sometimes if you are trying to remove from an empty list, like that's what we call underflow. The list has no element what you are trying to remove. So in such a situation, it will show you an error because you are trying to remove then there is no element. Exception will be generated. But if you use poll method, then it will not show any exception. It will not remove anything. It will just go ahead, but it will not generate any exception. But remove method will generate an exception. But please be aware, poll and offer can only be done for queue type of reference. I mean, queue type of references or queue type of objects. Okay. Fine. And then we are coming for this priority queue. Now this is heap. Nothing different, same thing. Only thing is again you add offer, peak, poll, everything is same. Only thing, the new thing in priority queue is this is also a queue and we are defining it as this priority queue. Here we are not using linked list. Okay, although we call it queue, priority queue, but this is not actually a queue. This is something completely different. This is basically what we call heap. Okay, so this is heap. So in this case, don't think that I told you that it is queue, so we will write linked list. No, here you have to write this priority queue class only. Okay, now what is the benefit? What is the main point of this priority queue class? So here it will allow you to get element on the basis of some priority field. Priority field means, so in the previous case, what was poll method doing? Poll method was simply removing, removing element from the back, so from the front of the linked list, right? From general, I mean, if you see the definition, retrieves and removes the head of this queue, or returns null if the queue is empty, right? So the whatever is the front of the queue, it will return that value, and if there are no elements in the queue, it will return a null value. So it is returning whatever element is present in the front of the linked list. In priority queue, it will not return. The poll method of priority queue will not return what is there in the front. What it will return those values which are highest in priority among the values present in the priority queue. So what do we mean by highest in priority? So there will be some field which will have the priority, I mean, which will decide the priority of the element present inside the priority queue. Now, if you have some integer values inside the priority queue, then the field is very normal. It is trivial. It is numeric value. So whichever value will have the lowest numeric value, that has the highest priority. By default, we do by ascending order, right? So basically, when you write the poll method, it will not return the element which is in the front, but it will return the element which is the smallest among all the elements present in the priority queue. Again you poll, again it will return the next smallest element. Again you poll, again it will return the next smallest element. So because the priority in case of numeric value is the lesser place value of the number. Getting the point. But when you define an object, the priority queue is made up of not integer but custom objects, student type, employee type, some other object. So then what to do? Again same funda, we will use the same concept. We will not make any changes in poll method or anything else. Everything else will remain same. Only thing that we have to do is go into that student object class. In that class, implement comparable interface, override the compare to method, and that's it. Once you do that, the poll method of priority queue will automatically call the compare to method, and every time it will return the next highest priority element on the basis of your definition of the compare to method. Okay. So yeah, again, this poll method is only thing that is different for priority queue, and it returns on the basis of priority. Customizing the elemental comparison is very essential for priority queue users. We will therefore visit it. So this is something else. We have already seen this. Okay, so there is something again else. You can see that later. Okay, one code is left that I will not discuss today, and that is the map. Only one part is left, map. I have discussed all the other data structures. Map also, the fundamental concept I have discussed. You see this hash code method that I told you, an equals method, this hash code and equals you have to override. Okay, so these two things I would request you to watch the code walkthrough session, and also in the subsequent OPP coding sessions, OPP guidance sessions that you will have, I think on Friday, Thursday, I don't know. Yeah, so maybe on Friday and Thursday, you guys can ask your doubts, and yeah, so.
Sir, can you share this code?
I will make sure these codes are shared from not only this, from week 1 to week 6, all the codes are shared by tomorrow maybe. Okay, not maybe, tomorrow. Just write in discourse if the codes are not shared by tomorrow morning, or by latest by tomorrow afternoon. If the codes are not shared till tomorrow afternoon, then write a discourse post. Okay. Tagging me and maybe all the other instructors as well. Hopefully that will work better. But even if you do not get the code, the live walkthrough session is already released, so you can watch. These are the same code that I have used to discuss the things that I wanted to discuss. So all the concepts are discussed there. So that's why I'm saying watch that. Okay, if you need, slow it down and watch that. but watch that. All these concepts are discussed there. Fine. Okay. Anyways, so I think we will not go any further today. It's already 9:15. Map is left. I don't want to do map today now. Map will be discussed in the next session. I will tell them. And also you guys can see that recorded session of week 6 code walkthrough session. In both the things, maps are discussed in detail. Please watch it. Okay.
Sir, OPP will be on Saturday, right?
Sorry, what?
No, OPP will be on Saturday.
19th. 19th is what?
Oh,
Yes.
people, sir.
Yes,
Saturday.
sir.
Fine.
Sir, and there will be total like 4 questions, sir.
There will be 4 questions. You guys have to do 3. I mean, there are some challenge questions as well. There are some bonus marks with the challenge questions. So if you do a challenge question, then I don't know what are the conditions for that, but you guys will get some bonus marks and some stuff like that, maybe badges and something. Yeah, I don't know the exact particulars, but 4 questions will be given. 3 questions you have to solve compulsorily out of those 4 questions. And you can do 4 also, but 3 is compulsory. And if you do all 4 of them, and then still you have time, then you can solve some challenge questions. Just bonus questions are given. So if you solve that, then you might get some grace marks. Not grace marks, what I mean is some bonus marks or some other things as well.
Sir, what was that?
Sorry, Disha, go ahead.
Sir, what was the timing? Like, how many hours?
I think 1.5 hours, right? Someone else can also corroborate. I think 1.5 hours. Let me just
Yes,
check.
1.5.
Yeah.
So those 3 questions will contribute to 100 marks, right?
You do the 3 questions, you get 100 marks.
Okay.
Any 3.
And
Any 3.
sir,
Anything else?
So we have received mail regarding the answer key, but I don't think the link is shared to check the response key
Answer key.
in the mail. Even in portal also it's not there.
Answer key for what?
Of quiz 1.
Quiz 1 answer key.
it's there in mock.
Response key. So answer key to we'll get.
It's there in mock.
It's under the mock in the course.
But our own no, it's not there in my.
Score checker is not released yet. Only that answer key released.
Even the mail doesn't have any link to check. Like if you can provide the link, it will be easier in the mail.
I think someone has written something. Let
In
me just.
mock section. It was there last mock.
What is this drive link?
This is the answer key, right? Our own response key is not there. Link.
Okay, so let me just message the administrative people.
That was not released yet. Only question key was released.
Fine. Anything else? I will tell them. Let me just ask them.
Sir, to practice for the OPP, like I've done the mock questions, and I think there is some discourse also. Ma'am Kubra ma'am, I think she has shared. So, is there any other like site or questions? Do you know?
No site needed. Just see the practice and grade it. Yeah, you want to practice using some site and all, very good. Go ahead and do as much as you want. But if you want just how much is needed, see the practice graded question, whatever is there, try to complete all of them. And yeah, if you see the examples that we have taken in the coding sessions, in the live session as well as in the. So let me ask you this question. So in the previous live sessions, how it was taught or how it is taught, maybe some coding examples are taken, right?
Yes, sir. Some. Yeah.
Yes, sir.
So those coding examples which were taught, right? And also the, all the live session coding examples, as well as the code walkthrough session coding examples. If you go through all of them and practice question, graded question. So whatever the course content is there, okay, if you go through all of them properly, then you not only can solve OPP question, you can solve most of the other outside website question also, right? But you have to go through all of them, because if you just see practice and graded question, there are 4 questions, I think, 2 practice question, 2 graded question. That would not suffice you to create concepts. But if you see all the live session concept questions as well as the code walkthrough session concept questions with the PQGQ, then I think it will be enough for you to solve any kind of OPP or any kind of other questions as well. So yeah, that's why I'm again and again saying focus on the live sessions and also focus on the code walkthrough sessions.
Okay, sir. Thank you.
So
Sir.
is there any segregation between from question 1, which topics will be covered in
No.
question 1?
No.
Nothing like that.
4 questions you will get, 4 on different concepts. Okay. Now in Java, you can see in any programming languages, once you proceed, all the previous week's ideas are coming into current week, right? So let's say we did the code of this collection type. Collection type had generics. Collection types had function overriding. It had interfaces, polymer, all those things are there. So basically collections has all the concepts which are in the previous weeks. Most of the concepts which are there in the previous weeks, right? So that's why it's not like that also, that you will have very much segregation of concepts and something like that. But what I will say is there will be 4 questions, and 2 of them will be mostly completely from the initial part of the course, initial weeks. 2 of them will be from the later weeks. Maybe basically 2 of them will be from collections and your generics and stuffs like that. 2 of them will be from your initial part, which is basically interface, class, function overriding, all these things. Okay. Yeah. So that's how it will be.
It could be generic also. Generic.
Yeah.
week
Generic
5.
is there. I mean, generic is week
Yes.
5, right? Generic obviously will be there. In fact, generic and collection are the 2 important things for your OPP. Other things are anyway interference. Sorry, not interference. Interface and this polymorphism. These are anyway in generics, and all these things are utilized. All those concepts are already utilized in these codes, right? So you don't have to. So yeah, focus on those parts.
And reflection. Like
Reflection is not there. Not important.
Okay.
Reflection, don't worry. I told you in the, I think in one of the live session, one of the instructor also told, or I also told in the walkthrough session, you don't have to worry about reflection, because it is primarily used in the production site when you are actually developing software and going through it. Sir has also told that in the lectures. Yeah, Suresh, go ahead.
Sir, there is one more OPP for Java.
And 19th one is there, and I think 22 or 20.
20th is one. So
20.
what I was trying to ask is, so is the OPP2 a re-attempt of the OPP1?
No. Both are separate.
Okay. So is there a re-attempt for OPP1?
I am not yet decided, but on the basis of some result, we will discuss whether that is needed or not.
Okay.
Okay. Let me just confirm it for others as well. You guys might know it, but still. It is on July 20th. July 20, you have another OPP. Okay, that is your another. It's not reattempt or anything. It's just a completely different. So some people who will be busy on, not busy. Basically, it's impossible for them to attempt on 19th. They will do it on the other day, on 20th.
Yes, so for me it's 20th.
Oh, for
Like
you
it
it
will
is
be
20th.
auto allocated.
I don't know. If you are not, I think it is auto allocated, but if someone raises any concern, I think they will change it to 20. Or I don't know. I don't know how the admin side works. So yeah, Suresh, you can might.
Standalone students, they schedule for 19th.
Sorry, Disha, can you repeat? I couldn't get.
For standalone students, they schedule for 19th, and for
Oh,
working
acha,
professionals.
Okay, okay. Okay, so students kind of schedule, fine. So anyways, so the levels, difficulty level will be same only. So don't worry about that.
So
Fine.
similar to mock.
Similar to mock OPP is on tomorrow, right? Tomorrow or day after tomorrow, I think, right? Mock OPP.
I think
The
they
mock was released.
released actually.
Oh, mock is
It was,
released.
Yeah, there are
yes,
few
yes.
questions.
Let me check. Uh, Just okay, yeah.